Okay. Ah. Someone mentioned I always start everything like that. Okay. But anyways, this is the 2020 Northwest Mathematics Paper 1 memo. I'm not gonna waste your time. I am just gonna dive straight into the paper. And the big idea is whatever we're gonna be doing, anything that is not clear, I suggest you do yourself a favor and enroll yourself onto the all access pass. Now the funny okay, it's not a funny thing, I'm just plugging you. As of this recording, you see, like this recording, it is currently like the 26th of October 2021. There is a 50% off sale that's currently going on, and this is the coupon code BYB50. You're gonna get 50% off absolutely everything on the course platform as of today, because as of this recording, this is like the 26th of the 21st year. This is going to run all the way until the end of November, so let's say 30/11/21, you see. So let me just put this so that on the PDF file it shows, you see. Let's say here 50% off everything. And then here, as we have put, I'm sorry if I'm wasting your time, and if this is like, months in the future, this is just going to be a discount code. You see, this is like a coupon code here. Let's say here, coupon code. You see, so at checkout, you can just put in the BYB50. And if you want to make a payment via EFT, then you can always just send me an email, or you can always WhatsApp me, or you can contact me on IG. He saw as my IG handle, you see. Or again, you can always contact me via email, you see, for the EFT details, levy@brightyoungbrains.co.za. I'm literally starting a video and I'm like saying all these darn things. I'm sorry. I'm so sorry. I just want to like get this out of the way because it is important. So yeah, email is like levy@brightyoungbrains.co.za. brightyoungbrains.co.za. This is also if you want to inquire more about the discount and everything like that. So what else can I say? Yeah, you can always hit me up on IG, or you can hit me up on WhatsApp. I'll always give you the WhatsApp number if you hit me up on IG first, you see. Anyways, let us start with the video. Sorry for all that. So for x, well, nothing to it here, Solving for x, we know that it is just a matter of using the quadratic formula here. So x is equal to minus b plus minus b squared minus 4ac over 2a, right? And then the value of b here is going to be a -7. There's nothing, when you're going to be working out a value for x, and you can see that the question is like easy. You have to remember that these first few questions, they're literally warm-up questions, like literally free warm-up questions that everyone is expected to get like 4 marks for, you see. Like no one has an excuse for not getting marks for these questions. So please don't put yourself in a situation where you make like a silly dumb mistake right in the beginning, because I'm like, why? Why? So this question, if you put everything in the calculator, let's see what we're going to get here in the calculator. The calculator is going to give us 1.08, or x is going to be equal to -0.31. Okay, moving on. So obviously, as we're solving for x here, there is an algebra course on the course platform, you see, where you can go through question 1 questions and all that stuff, and how to answer those kinds of questions, more complicated ones obviously. So solving for x here, this is like an inequality for 3 marks. This kind of a question, this is how you have to go about it. You have to make sure that this is in standard form, meaning it's a quadratic equation. So fortunately here you can already see it's going to draw a parabola. You're going to draw a rough sketch of a parabola, and then with this rough sketch you can see it's a smiling parabola because this is a positive number. And then you also want to just draw an x-axis. With this x-axis that you have drawn, you want to answer this question: where is this parabola having y values that are bigger than 0? Because remember, this is the equation of the graph, and remember the equation of a graph is always in the form y is equal to something. So this question is practically asking you where are the y values bigger than 0. And if you look at your sketch, the y values are bigger than 0 here. You see, this is the part where your y values are bigger than 0, because remember, down here it's values that are negative, up here it's values that are positive. Now the question, them asking you to solve for x, you see, they want you to give the x values that are producing this part up here and the x values that are producing this part up here, of which you can see that those are x values going to the right here and x values going to the left over there. You see, let me just remove that so that we don't have like too many arrows everywhere. So that's how you're going to answer the question. You need to find out what x value this is, and you need to find out what x value this is, and then you need to say that your graph is above 0 where x is below this number and where x is above that number. Whew, let us begin. Solving for x here, it is the reason why you make this thing equal to 0, because you want to find out what this is specifically at 0 and what this is specifically at 0, so you can work out where is it above 0 there. So here, solving for x, it doesn't look like we're gonna do anything crazy. You can just take out 5x as a common factor. It's gonna leave you with like 2 here, then let's say equal to 0. So this is gonna be 5x is equal to 0 or x minus 2 is equal to 0. So this is gonna give you x is equal to 2 or x is equal to like 0. Yeah, because if you divide by 5 here, it's going to be a 0. So I once saw on like a learner's paper where they had written or, right, in an inequality question, and then the teacher scratched it out and put and there, and then they gave the learner like 2 marks less out of 4. I was like so furious, because I mean, like, how can you put and here? You see, and is like, it doesn't make any sense. So if you get stuff like that in your papers after they've been marked, please go fight for your marks, you know, because you cannot have a person cancelling or here and putting and saying that that makes sense, because remember, a number cannot be equal to 2 and equal to 0. You see, it doesn't make any sense. It has to be one of the two, even if you write it as an inequality at the end of the day, like what we're about to do now. So here what we know is O is correct, right? So here x is a 2 and a 0. So here you already know this is a 0, this is a 2. So now you can clearly see that your answers, x has to be bigger than 2 or x has to be smaller than 0. You see, it's definitely an O. So if you write O and they cancel it out and they write an and there, as I mentioned, go fight for your marks. Okay, I feel like after every question, let me actually copy this thing here, because to be honest, I'm gonna be plugging this the whole day, so please forgive me, because it is important, you know. There are a few days left, and yeah, man. So before I start with the question, let me just paste this over here, down here. I'm sorry. I'm literally gonna have this everywhere. It's gonna be so awkward when I release the PDF file for this thing, and it's like you're watching this maybe like days, or not days, like maybe like a few months after the thing. But with this 50% off code, I mean, like, hit me up, even if it's way after this day here. Just hit me up, and who knows, maybe it may be your lucky day. So let's see here. For 6 marks, they want you to solve for x here. Let us see what you gotta do. What you gonna do here? You're gonna take, I would prefer taking this. You see, this here has a negative, this is together, so you can take this to the right hand side and take never mind, let's just leave it here. But what I can safely say is, anytime you see a square root, right, you have to check your answers at the end, because usually only one of them will be correct. So let's say here, check answer at the end. Excuse me. Okay, so let's see. What do I want to do here? Yeah, so this is like a square root symbol here. Just check your answer, you see, at the end, because that's what the square root symbol normally does. You'll have 2 answers, but one is correct. So here, let me just take the 4 over to the other side. It's going to be like 3 minus 4. That's like a -1, right? So having to have done this, clearly you can clearly see that we can just square both sides, because we're trying to solve for x here. And don't mind me, you know, if you multiply this by itself, you're obviously going to end up with x plus 1 only. You see, I mean x plus 5, and then this is equal to x minus 1, x minus 1. Now here on the right, let's see, x squared minus 2x plus 1. This is just after you've FOILed. And then you have x plus 5 over here. Everything to one side. Let's see, negative 2x. You're going to minus an x there. So it's like negative 3x. 1 minus a 4, 5 there. And 1 minus 5 is going to be like a 4 here. Because remember, you're taking everything to the right hand side. Yeah, I'm kind of flowing, man, because I do not want to spend ages on this paper. I want to flow as fast as I can, but explain as much as I can at the same time, you know? Here, it is what it is. So here, let's just solve for x. Negative b plus minus. This formula is on your formula sheet, so I'm like, you know what I'm saying? Don't get it wrong. BAC over 2a, x is equal to, what is minus b? Minus 3 plus the minus, let's see, b squared. B squared is going to be like negative 3 squared. 3. It's so nice saying 3 instead of 3. Yeah. Don't say I did that on purpose or whatever. Oh, I said 3 wrong and now I'm like covering up. No. I wanted to say 3 and I said 3. Okay, so why am I defending myself when there's no fun? When there's no one fighting with me? Yeah, ne? Anyways, let's see what this gives us. Wait, I don't have to check the calculator. I'm like, I could have factorized here as well. For those that like factorizing, let me humor you here. Factors of 4 that can give us a 3, it's just 4 and 1. For us to get a negative 4, then these have to have different signs. And then for us to get a negative 3, it clearly has to be negative 4 plus 1. There you go. I already have factorized, so I know the answers. You see, x is a 4, or x is going to be like a negative 1. Because remember, you take turns with the brackets. First bracket equal to 0, second bracket equal to 0. And you only do that if the right-hand side is fully equal to 0. If this was not a 0, you cannot do this. You see, you cannot make one bracket equal to 0 first and then the other bracket equal to 0 after. I'm saying if this is not a 0. You see, if this is a 5, you cannot do this. You see, you're only doing this because, remember, multiplying two things, you can get a 0 if either one of them is a 0. That's why you test out where either one of them is going to be a 0, and then you get two answers. Woo! Let us move on. Let us move on. Let's see, excuse me. For 1 mark, it says, if x minus 3 times this is equal to 0, determine x if y is a 4. Oh, wait, I remember we said you have to double check answers. So one of them is definitely going to be correct. So let's test a 4. 4 here, you'll have 4 plus 5, which is 9. Square root of 9, that's a 3. So here it's like 4 minus 3. So you see, this doesn't work out. Negative 1, let's see, you have negative 1 here plus 5, that's like a 4. Square root of 4, that's a 2. 4 minus 2. I feel like I have to double check this because I was just rushing there. 4 minus 2, that would be like a 2. And then here you have like minus 1 plus 3. Yeah, this works out. I feel like I need to double check this, even though I'm confident. This is a 4 plus 5, which is 9. Square root of 9, that's a 3. 4 minus 3, that's a 1. And then here it was going to be like a 4 plus 3. Yeah, this doesn't work out. This works out. So again, always double check the answers. 1 mark question. Oh, they had said here, if this times this is a 0, determine x. No, if y is a 4, determine x. Well, that's like plain simple. Like 3 mark, you see. All these, remember, just warm up. Nice warm up questions. It's almost like warming up your hand, you know, and warming up your ink, getting it to flow down the pen, you know. Because I'm like, you know, like, come on now, you know. So this is obviously going to be, you can put 8 in the front here now, and then x minus 3 equal to 0. Doesn't matter if this is here or this is in the front. It really doesn't matter. So here it's going to be 8x minus 24. Is it 24? Hey, my 8 times table is 8. They were failing me there. And don't make the mistake of saying something like 8 is 0 and then this bracket is equal to 0. Come on now. Don't do stuff like that, you know. So let's see here. Divide both sides by 8. What you gonna get? What you gonna get? X is equal to a 3. 3. Let's see here. 3 minus 3, that would have been a 0. So 0 times anything is a 0. Nice. If y was a negative 4, let's see what that would have given us. Let's actually zoom in because the boy is running out of space. The boy thought he was smart. Let's see here. This is going to be negative 4. Come on, bro. This is a 1 mark question. This is the dumbest 1 mark question I have ever seen. What is it? Oh, it's a 1 mark question. Well, here 4 minus 4, negative 4 plus 4 is a 0. No, negative 4 plus 4 is 0 times this is equal to 0. Then you'll have 0 is equal to 0. But they're asking what x is. For this kind of a question, you can literally end up saying something like x is an element of R, because regardless of whatever x is, this will always be equal to 0, because 4 minus 4 automatically gives you a 0 anyways, you know. So this is one of those questions where you're low-key thinking outside the box, but at the same time it's like, yeah, it's really not that complicated. X can be any number because this will always be a 0 anyways, you see. So 0 times anything is 0. Your reminder of the, you know what, let me be generous with this recording, you know. Regardless of what year it is, what day it is, hey, this is gonna be tricky, man. This is gonna be tricky. But I guess if someone is lucky enough to have bumped into this, well, I'll just do this. If this day is not the time that you're watching, if it's already past this thing, just hit me up if you're really willing to like make a purchase, and then I'll create a code for you. If it's not this one, this one is not valid or something, or I'll just we'll make a plan, you know. But if it is between the 26th of October, well, I forgot to put October here. Hey, boy, Brody, come on, man. What day is it today? 26th of the 10th of the 21st. Yeah, if it's past these days here, if you're really keen on making a purchase and you're not like just being funky, you're like 100% certain, just hit me up. I'll hook you up. So 6 marks here. It says solve simultaneously for x and y. Super duper simple question this. Oh, you ask such simple questions, but we like to see it. Thank you very much. So here looks like the easiest thing to do is to just isolate x. And if you've been following through and going through papers on this channel, yeah, after going through a few papers, I'm sure you'll see the trend, like, you know, it gets easier. But anyways, let's see here. Let's throw 1 into this equation here. You're gonna have, remember, this is your value of x, right? So it's gonna be like x squared plus y squared is equal to y minus 1 minus 2y. Please note how I've used brackets here, because if you don't use brackets, you're gonna be in trouble, man. You're gonna be in trouble. So here, let me just foil. Let me do it nicely so that I don't lose marks unnecessarily, you know what I'm saying? So let's see here. 1 times 1 is a 1. 1 times that is a negative 2y. Another negative 2y. So I am loving the flow here. I wish I finished soon, but it is what it is, man. You know, gotta put in the work, you know, gotta put in the work. So let us see here. Let us see what we're gonna get here. This is gonna be like 1 minus 4y. So technically, let me just make this easier for everyone. This is gonna cancel. These are all gonna cancel each other out, you see. And then 1 plus that. Let's see. 1. Whoa! What just happened here? This is weird. This times that. Yeah. What in the hell just happened here? Yo, this is weird. Like, it's so weird. Like, legit though. Like, when's in Johnny? You know, when's in Johnny, bro? Yo, what had happened there? Yo, that was weird. Like, legit. This times this is that. This times this is that. Da. Oh, oopsie. Hey, the boy is getting confused. Yo. The boy is getting confused. Yes, like, man, I might as well do it again. This times this is that. This times this is that. This times this is that. This times that is that over there. Oh, this cannot cancel out because there's a square. Me. Hey, yeah, ne. Whew. Yeah, I guess I should slow down just a little bit. Just a little bit. Know what I'm saying? Yeah. Yeah, that was not embarrassing at all. Moving on. So this is going to be plus, this is going to be a 5 now. Because 4 plus 1 is a 5. Everything on one side, let's see. So, might as well take it to the left. Because I'm like, why not? You know, why not? Negative 5y squared. This, if you take it to the left, is going to be negative 7y. This, if you take it to the left, is going to be like plus 2 equal to 0. Nice. We are love to RC it. We are love to RC it. Yeah, everything looks good. I was like taking a second to just double check the answer. I'm gonna run out of space here, but we can make it work, you know. Y is equal to minus b plus minus b squared minus 4ac over 2a, because the quadratic equation works, man. Like, he or she who hates the quadratic formula, me, I just don't know. Like, it's just a strange thing to hate such a formula that works, you know. So here you're gonna have y is equal to minus b. What is it now? Minus negative 7. Gonna put a negative 7 over there. What is a now? A. Oh, a is 5. Sounded like I was shouting there, but nope. I was looking for a. This is like over 2a. A is like 5. So let us put all this into the calcu of the later. Get it? The calcu of the later. Okay, that doesn't make any sense, because like, what is the calcu of the later? The calculator, but still though, it doesn't make any sense, Brody. It doesn't make any sense, man. Let me see here. So let's see in the calculator. Put this on the calculator. We are getting our value for y. We're gonna get 1 and 2 over 5. You see. So here let's just put the 1 and then 2 over 5. So that is what we are getting for our value for y. See, so this value for y, in terms of us getting a value for x, we can just throw everything into the calculator. Can we throw everything into the calculator? I guess we can. For y, let's just put it into the thing. Here you're gonna get, let's use a different color, you know, because why not, you know, 2y, no. Okay, let me just, come on now. Where y is, let's just throw in these numbers. Let's say throw in a 1 there. You're gonna get x is equal to 1. So this is gonna be like 2. 2 goes over, it's like x is equal to negative 1. So that is the answer that we're getting for x. That's like one of our x values. The other x value, let's see what we're gonna get here. You're gonna put a y here as like 2 over 5. Let's see, this is like 4 over 5. So if you take it over, it's going to be 1 minus 4 over 5. So x is going to be equal to 1 over 5. Nice. I almost dropped the z. Never mind. Moving on. For 3 marks only. Ooh, this question, I've bumped into this question before. But anyways, this question says, consider this, right? The left-hand side, it is equal to this right-hand side, where k is a constant. And qx is a polynomial in terms of x. Calculate k. So the easiest way to do this is, you have to remember that x plus 2 multiplied by this plus 10 is equal to this, you see. So remember, this multiplied out gives you this. So I'm going to show you something super simple here. You have to remember that x plus 2, if you throw it into, if you equate this to 0, you're gonna get x is equal to negative 2. Now the big idea here is, if you know your polynomials, you know, just basic polynomials, if you throw negative 2 into the equation of 5x squared minus kx plus 10, you're gonna get a remainder of 10. Let me just make this simple. You see, if you this here into equation remainder is 10, you see. because this is telling you that this, if it's factorized right, this is the best that you can do, and then there will be like 10 as a remainder. This is showing you that if you throw -2 into this equation here, your answer will have a remainder of 10, meaning that your answer will be equal to this 10 over here. So here you can basically just say 5 with -2 here squared minus k with what? -2 here, and then plus 16 equal to 10. So I'll show you the way I'm doing it now, and then I'll show you how I did it. I remember going through a question exactly like this, and this is one of the questions that I threw into the algebra course. Yeah, I'll show it to you. So here it's like -2 squared, right? It's a 4. 4 times 5 is a 20, and then here it's gonna be positive 2k actually, and then plus 16 equal to 10. And then here this is gonna be 20 plus 16, that's like 36, plus 2k equal to 0. 2k is equal to like -36, k is equal to like -18. This is how I've done it here for 3 marks. Let me show you how I did it in the in the algebra course. So let me just go to the algebra course quickly. I just want to show you something. Algebra course, come on bro, algebra course, where are you? Like I want to go to the files for like the algebra course, because I want to show you something. Let me do thumbnail so that I can I can't see the thing. What did I even write it as? What did I name it? The PDF file with like the answers. Oh man, let me try this one. Come on. Really? Let me just check. Hopefully this one has, and I hope it's not like empty or anything. Like excuse me for like sidetracking, but anyways, this here I just want to show you what I did for like this particular question, because I remember it was one of the questions I threw into the course. Because with the courses, it's remember each chapter or each topic is broken. No, each topic in your syllabus is broken up into different chapters, of which in those different chapters you basically learn tricks and skills on how to like tackle those kinds of questions and everything like that. So me, I just need to find, see, this is the question as I mentioned, and you can see here in the course I did it a different way. I showed you like a different way that you could have approached this question, you see. So you can take a screenshot of this, and then you can always analyze it later on to see if it makes sense. And then obviously this is in the algebra course, and as I said already, because I am feeling generous, whatever day it is, if you really are willing to make a purchase, just hit me up, and then I can allocate a code for you if this is not still valid. So anyways, moving on. Okay, we are looking at sequences and series as it seems. Sequence and series. What does sequence and series say? I feel so tempted to plug myself again. Okay, let me just do this quickly so that we don't waste people's time, and you can obviously like skip through to when I have stopped. So I'll just put this over here just so that you know what's up, and if you're interested in it, you can always just hit me up. Oh man, it's gonna cut it. Nah, it's fine. Anyways, so Anne plans to start studying for her grade 12 final examination. As of this recording, there's like 9 days until the final. So on the first day, she studies 1 hour, which is like 60 minutes. And then it says she plans to increase the study time with 15 minutes per day. Nice. And then it says as soon as Anne reaches 6 hours study time, she will continue to study for 6 hours each day thereafter. What a wow, man. Oh, interesting fact. Oh wow, I feel like I should drop this in here now while I still have the chance. Interesting fact, is if you spend 6 hours per day on the courses, right? 6 hours per day on the courses on our website. If you do that for 10 days, that's going to be 60 hours of work. And everything on the course platform, the entire math syllabus, starting from algebra all the way to like Euclidean Geometry in paper 2, everything is just 60 hours total on our website. Meaning in a space of 60 hours, you will have gone through the entire syllabus. So if you're upgrading, or if you want to work on your own, then I suggest you visit the course platform, because the entire syllabus is in 60 hours. Let me even put here entire syllabus in 60 hours. Like literally I posted the post saying that it takes 6 hours to go through the entire syllabus. So meaning in a space of 10 days, if you go through the courses in 10 days, 6 hours every day, you'll be done with the whole syllabus, and then you can move on to other things, like you see there's past papers and whatever. But anyways, question number 3 here, with all this being said, they said she's starting off with like just 60 hours. You see here, 60 hours, and then every day she's adding 15 minutes. You see, 15 minutes every single day she's adding. So here this is like gonna be like 90, I think. Going on and on and on. This is like the sequence of her study time in hours. I mean in minutes. So it says here, calculate the number of hours N will study on the 10th day. So we just have to get the general term for this sequence, you see, of which it's an arithmetic sequence here, because we're just adding 15 every time. You see, the formula of an arithmetic sequence, it's on your formula sheet, you know, it's on your formula sheet. And it doesn't matter what time of the year you're watching this. If you have not started using your formula sheet, please do, you know. So here A, we know it's like we have to get our general. We don't have to get the general term first. We can just jump straight to getting the number of hours on the 10th day, because this is like T10. A is the first term, right, which is the first hours in the first day, which is 60. N is going to be a 10. Our common difference, we know it's just 15 every time. And then this, you want to put it into your calculator. So calculator, please do the things so that we can move on with our life. So let's see here. In the calculator, this is going to give us 3 hours and 25 minutes. I mean 3 hours and 25 minutes, but obviously 3 hours and 25 minutes, when you put, remember in your calculator, this is going to come out as minutes. You see, so it's going to come out as like 205, you see, of which this is equal to 3 hours. What did they ask here? How many hours? You see, so 2 hours, it's gonna be, remember, 3, this you can divide by 3. You see, in your calculator, if you say 205 divided by 3, let's see what you're gonna get. 200, and oh no, you have to divide by 60, because each hour is like thingy. So to just complicate, good enough, bro, worry. Don't make it so complicated. Let me not make it so complicated. So the easiest thing to think about it is, here in terms of minutes, right, you're gonna have 180 minutes, which is equal to like 3 hours, and then from there you're gonna have like 25 minutes left over. So this is like, yeah, let's say here 3 hours, and then from 180, this minus 180 gives you a leftover of like 25. So this is basically what you can do to like work out your hours and your minutes. But then if you really want a simple method, which I really should show, because I think what I said may have been a bit vague, this is your minutes now. All you're gonna do is you're gonna say 205 divided by 60. It's gonna give you 3.4 something. Let's see here. In the calculator, 205 divided by 60 is gonna give you 3.416666. Let's say 41 here. And then how many sixes are those? There's like 5 of them. 1, 2, 3, 4, 5, and then 7. So this is the hours, né? The 3 part. You see, this is already your hours. This part here, you have to multiply by 60. You see, the 0, you have to say this is just 3 hours. This part here is just 0.41666667. You're going to multiply this by 60. This is going to give you 25 minutes. You see, this is how we converted the leftover hours to minutes. So here, that's how we end up with, therefore, 3 hours 25 minutes as the final answer. Let me just maybe give that like, you know, a different color so that it like, you know, stands out and stuff like that. Really now, bro? Or really now? What did this? What did you? Yeah, I feel like I'm gonna lose my words if I keep trying to say weird things. Anyways, for 2 marks here, let's move on. It says determine which day n will reach 6 hours. So remember, our formula works in minutes. So 6 hours, you have to convert it to minutes first before you can do anything, you know. Otherwise, you're going to have a problem, you know. You're going to have a trouble. Going to have a trouble. That is actually quite funny. Or is it? I don't know. But me, I laughed already. So if you didn't laugh, hey, that's on you, bro. I'm not responsible for your laughter. So let's see. 360 minutes is what we're aiming for. In our formula, we want to see which day it reaches 360. So it just means where Tn is, you're going to put 360. A, we said it's 60. N, we don't know because we're looking for the day where it reaches 360 minutes. Our D is just a 15. Multiply this inside, you're gonna get 15n minus 15. This is like 360. Oh, come on, bro. And then what? Everything on one side except for the 15n here, you're gonna get I'm lazy to do the calculations here. 360 minus 60 plus 15 equals to like 15n. So this is like going to be 300 plus 15. So it's like 315. And then you're gonna divide by 15 on both sides. I wonder what that is going to give us, huh? Let us check in the calculator. Calculator, please do the honors and, you know, give us what it is that we are want to our get. 2 point. So in this question, we know that it's just gonna be n. It's gonna be 21. It's gonna be 21, man. 21. If you want to check it out, you can just say 15 times 21. I mean, like, duh. I mean, like, it is a calculator. Why would the calculator lie to you? Huh? Why would... but hey, it depends on what you give the calculator, because the calculator always tells the truth. It just depends on which kind of a truth it is, depending on the things that you put in it. Hey, let me stop being weird. Or I don't think that was weird. Let me just stop being saying unnecessary stuff, you know. So I'm trying to choose a nice color here, and it's so hard. Let me just change because these are so boring. Oh, this is interesting, I think. Okay, no, it's not. So where am I? For 4 marks, it says calculate the total number of hours that n will study in the first 30 days. So total number of hours, which this question was asking in terms of what? Oh, determine on which day. Okay, day 21. If you didn't write that portion where it says day 21, it's really not a big issue. Here they say the total number of hours. So clearly remember our formula, we're going to use the SN formula, but then you have to remember that this SN formula is still going to work in terms of like minutes. We just have to change it to hours afterwards. So they want us to work out the total number of hours after 30 days. So S30 is what we're looking for. N is going to be a 30. A is a 60, as we already know. N, what is N? N is your 30. And then the D is like 15. So this question is quite straightforward. This bracket is obviously super duper important, or those brackets are important, otherwise your answer does not work out. I feel like you've bumped into that quite a few times, eh? And you've seen that it doesn't or do. But let's see here. Oh, snap. We have to be careful with this question, actually. Let me actually scrap this question out, because this is where I was about to go off so hard. But let me leave the formula. Let's scratch this out. The reason why you need to scratch this out is because this kind of a question you need to think outside the box. Because they say calculate the total number of hours that n will study in the first 30 days. So remember, here we have to remember that they said when she reaches 6 hours, she wants to only study 6 hours daily. So here you see, this is like a hint. Determine on which day she will study 6 hours. Oh, so after the 21st, on the 21st day, she will reach 6 hours, right? And then after every day after that, she's only going to be studying for 6 hours. She's not going to increase. So what we actually need to do is we have to work out the total for the first 21 days plus the next 9 days plus next 9 days, you see, of which the next 9 days will just be like 6 hours times 9, you see. So this part here is just gonna be 6 hours times 9, in addition to like the total of the 21 days here. So we have to work out the sum of the first 21 terms. These here will give us the sum of the minutes studied in the first 21 days, because remember at day 21 she reaches 6 hours. So I think the nice thing about these kinds of exams is that they give you hints, you know, like it's a big hint having to have asked when she reaches 6 minutes, because me halfway in the question I was like yeah, something is off, because it just seemed a bit simple. But here we are. Let's see here. Sum of the first 21, it's S21 is going to be, N is like 21, and then A, you can clearly see A is what was A again? A is 60, and then remember, if you're going to work in minutes, it's fine. If you have already been working in hours, it's okay. It's just a matter of converting. But I feel like working in minutes is like easy, and then just convert it to hours at the end. So this, let's see, in the R calculator, give us the answer. So our calculator in minutes, let us see. Let us see, what are you giving us? It is giving us 4,410, and we said divided by 60. Let's see what this gives us in our calculator. Divided by 60, that's going to be 73.5 hours, you see. So this 73.5 hours, we obviously need to add it to like the 6 times 9 over there, because if you don't add it to the 6 times 9 is you adding the rest of the days. So let's see here, 6 times 9, so it's like this hours, ne, plus I have to say plus what is 9 times, isn't this like 54? So the total hours is clearly going to be, let's see the calculator here, it's going to give us 127.5, 127.5. That's the way. All good. Anyways, oh snap, forgot to do the date. Let me remove the date thing, just so that people can feel free to ask nicely without worrying about the day and be like, oh, the day is passed. Nah, it's all good. If you're really keen, remember this is, yeah, you'll just see what happens when you do inquire and what day it is and stuff like that. So anyways, here it says prove that x plus y plus z forms a geometric series if log x plus log y plus log z forms an arithmetic series for 4 marks. You're not, is crazy, man. I'm like, how does a person even start with a question like this? Well, as I was saying that question, the first thing that popped into my mind was the mark allocation. It's a 4-mark question, so we do have to think a bit. We don't want to think too much, and we are still thinking of sequences and series. So yeah, they said here x plus y. Oh, okay. So the other thing that comes to mind is use your question to help you. You see here they said this forms a geometric series if this forms an arithmetic series. Oh, they say we should prove that this forms a geometric series if this forms an arithmetic series. So just use the properties of these two sequences, you see, because, or these two series. If this is geometric, then it means that y over x is equal to z over y. So if this forms a geometric series, it means that r is equal to y over x, or r is equal to z over y. Okay, that's what we already know, because this forms a geometric series. Now they said if this happens, then this forms an arithmetic series. So just exploit those properties. If this is an arithmetic series, then it means that log y, let me put here, log y minus log x is equal to log z minus log y. That is the way. Let me remove this color stuff here because it's like ruining everything, man. Like ruining everything, but it is what it is. So let's see here. What you're gonna do now? You're you see now. Nah, I think here it's easier to like maybe cross multiply. Let me not overthink it. So they say they prove that x plus this plus z forms a geometric series if log that forms an arithmetic one. Okay, so we can use properties of logs here. Remember this, this is more like the, what do they call it, you can use the division rule here, because if you have log something minus log something else, you can always convert it to log with this over x. This is like a log law. Same here, log z over y, z over y, and then this has a log, this has a log, so you can just drop the logs. Therefore y over x is equal to z over y. This is definitely this is what we refer to as the division rule with logs and stuff. You see, this is just the division rule. You see, division rule. I remember with like the NBT course on the course platform, there's an entire chapter where we went through like log laws and stuff like that. So if I go here to like the NBT course, let me see here, think if the courses, go to like the files for like the NBT course. The strange thing is, I don't even remember what day it was, but I think it was like day 18. Was it day 18? That's too far actually. Way too far. I feel like I'm gonna be guessing here to see what day it was when I did the log stuff, but I could always just pause and then look for it and then carry on. But like for some, there it is. Oh no, this logic, bro, come on. Find the thing already. Like let me actually pause and then find it and then carry on. I found it. It was day 11 in the NBT course, because the NBT course has like a lot of examples and stuff. So there's a portion in the NBT course where we went through like the log laws, you see, and here you have the division rule or the quotient rule, where you log something minus log something. If they have the same base, then you can write it as m over n with log with their base here, whatever this is, whatever that is. So in this case, you see our question here, if you look at your log, there is no specific visible base. Anytime you don't have a specific visible base, the base there by default is a 10. You see, so automatically these all have the same bases. You see, base of 10, base of 10, base of 10. But anyways, let us move on to the next question here for 3 marks. What did they say? Determine the ninth term in the sequence. Okay, that's quite easy. This is you don't know what kind of a series this is, but it looks like they're just dividing by 2 every time, you see. So technically you're multiplying by a half, you see, because 32 divided by this is a half, so you're multiplying by a half, multiplying by a half. So you already know it's arithmetic. Because it's arithmetic, think of your arithmetic formula, which is on your formula sheet. And then here, ninth terms, it's like T9 that you're looking for. So A here is like 64, R is like a half, N is like N. So working out a value, no, ninth term, bro. So N is a 9, man. Come on now, come on, maybe. This is gonna be a half to the power of 8. Don't even try any funny mental math. Just put it in the calculator, and then the calculator will give you the answer. In the calculator, let us see what we are get. The calculator, please give us the answer. Calculator, let's see. So the calculator says it is going to be a quarter. So the ninth term is going to be a quarter. You keep moving forward. The sum of determine the sum to infinity. Wow, I thought this not that paper was supposed to be the hard one. I think it gets hard later on. We'll see. A over 1 minus r. This is also on your formula sheet. We already worked out A to be like a half. So a half minus no. A is the top, bro. A is 64. Oopsie. I was messing up real good. So a is like 64, r is a half. Everything in the calculator, we are getting there 128 or 128. That's your sum to infinity. Yeah, sum to infinity, sum to infinite. I mean, like, same thing, maybe. Same thing, okay? Ain't no thing but little chicken wing. What did I just say? I said ain't no thing but a little chicken wing. I don't know where I heard that from, but it's nice. Just flows, flows on the tongue. Ain't no thing but a little chicken wing. But anyways, let's see here. Keep moving forward is what we are doing. What did it say? The quadratic number pattern, this, right, has the first term 2 and the general term of the first difference is given by this. Show that a is 2 for 3 marks. So this is an easy question as well, because you have a quadratic number pattern. You see, remember, this is what it looks like: t1, t2, t3, going on and on. You don't know what these numbers are, but then they said that the first term is equal to 2. So let me actually remove this and put a 2 there. And then they said here the general term, the general term of the first differences is given by this. So remember, your sequence of first differences is what you get down here, you see. So here you're going to get like t2 minus 2. Here you're going to get t3 minus t2, t3 minus t. Oh, did I put a 3 twice here? I'm sorry. Sorry. No, so it's like t4 minus t3, bro. Come on now. Come on now. t4 minus t3. There you go. And then you have the second common difference. You see, the second common difference would be down here. Whatever this is, it would be equal to whatever that is. Now, what they said is, you see these terms here in like the second stage. This is technically an arithmetic sequence, you see, because this arithmetic sequence here has a common difference. You see, this here is arithmetic. It's an arithmetic sequence. This arithmetic sequence, in this situation, we know we refer to it as the sequence of first differences. You see, let me put here at the top here, sequence of first differences. That's what this is. You see, it's a sequence of first differences. Now, this sequence of first differences has a general term, which is tn is equal to 6n plus 8. Okay, or let me just say 6n plus 8. So whatever this is given by 6n plus 8. Whatever this is given by 6n plus 8. So we can even see what this is going to be, you see, because this is going to be term number 1, term number 2, term number 3. Oh yeah, it's just crazy like that, it's just crazy like that. But let me not get too excited, because yeah, it's quite tricky, man, quite tricky. Excuse me. And I've run out of space already. Wow, bro, wow. Let me actually try and make sure I shrink all this together so that I don't run out of space, because the boy is just too excited, man. I'm so excited about something. So show that a is equal to a 3. So for this, for 3 marks, I would not overthink it. I'll just keep calm and use this. So what we know is that this first term here, what about it though? Well, we can get these two terms here, get a value for the common difference, and then work out a by saying that this is equal to like 2a. So let's try that and see if we're going to get a 3. So for the first term here, you would throw a 1 in there, right? So let's see. Throwing a 1 in there, you're going to get 6, 1 with like 8. And then throwing a 2 in there, you're going to get that. So let's compare these two numbers, because I want these two here so that I can get this, so we can get a there. This is 8 plus 6. What is 8 plus 6? 14. 8 plus 12 is like 20. So here minus that is going to be like 20 minus 14, which is like 6, right? Oh, dang it, man. Look at that. So 2a, 2a is equal to 6, so clearly a here is going to be equal to a positive 3, man. So it's like 2a divided by 2, 6 divided by 2, a is equal to 3. Wow, you see how easy it is. Super duper easy, man. Super duper easy. And many examples on working with the sequence of first differences can be found in the sequences and series course on the website. And remember, because you're watching this video, you have the opportunity to hit me up and request a 50% off coupon code on everything. But anyways, let us move on. Come on, man, let us move on. I might as well do that 50% off thing here. Let me paste it. Do the thing here. Come on, man, come on, just move it a little bit, move it a little bit. Nice. Okay, so determining the general term to this expression is not a hassle at all, because I mean, like, we have already done all the heavy lifting, you know. We've got an a. Now we just need to get, this is actually quite simple, because look, a plus b plus c is going to be equal to these two over there. This value, we know it's already like a 14, so it's like 3a plus b. Hey, but what did I just, wow, I wrote 3a plus 3ab plus, yeah, that was weird. That's some funny dyslexic whatever shandies. 14, let's throw it there, this one, and then 2a, we said it is equal to 6. So we already worked out a to be a 3, right? So here we can just throw in here, starting from the second one, 3 with the 3 here, plus b is equal to 14. This is like 6 plus the b. What you then got, man? What you then got? This is equal to like 14, and then b is equal to what? To 8, right? Yeah, man. And then here, obviously, 3 plus 8 plus c is equal to 2. You got the 11 plus c is equal to 2. And then this is like negative 9, I hope. Yeah. So here, therefore, Tn is equal to an squared plus our bn plus c. Very nice. Very easy 3 marks this. You see, don't find yourself ever losing these kinds of 3 marks in an exam, because it's like such cheap marks. And I made a mistake again. I hate making mistakes, man. I hate making mistakes so bad. Like, it sucks, man. It sucks. But let's see. Oh, I made a mistake here. I made it equal to, no, I didn't make a mistake. Oh, this is 9. Magangi. Ish. Yeah, this is like, I'm pretty sure you're gonna see me make a ton of mistakes, which is okay, I guess, you know. So that you can also see it's tough. It's tough here. It's tough. It's tough everywhere. So it's gonna be like a 5, meaning that this is all gonna be wrong. Ay. The walk of shame. Hey, yeah, well, you thought you were flowing. Now look back to square one. Let's see. This is equal to 2. It's gonna be 3 plus 5 plus c is equal to 2. I feel like I'm hopefully not making a mistake again. So this c is equal to negative 6. This is gonna be 5n minus 6. So the one thing I can say is always double check your answers, you see, because me, I had looked and I was like, what? 3 plus 3 is a 6, but 3 times 3 is a 9, my guy. So yes, like, hey, it is what it is, eh? Let us keep moving forward. Okay, so what does it say here? It says for 4 marks, given the series 17, 20, 23, going on and on with all these things. So what you need to focus on here, for 4 marks here, they say given this series, write the series in sigma notation. So this is going to be quite easy, because what you need to focus on is, you need to focus on each of these things individually. But then before you even focus on this, just know what kind of a format sigma requires. Anything in sigma notation, it just means that you're dealing with a series where things are being added up, you see, which is hence why we're seeing all this plus this plus this going on and on and on. So the first thing you do for your 4 marks is you write down your sigma symbol, you need to put three things into your answer. You're gonna put something at the top, something at the bottom. You see, I'm making sure it's like big. Did I just say bottom? Bottom. The bottom, my guy. What is bottom? It's bottom. And then you're gonna put something over there. So let's see. The first easiest thing to do is to put well, these two are the yeah, putting this and this is easy, but let's actually put this, because here you're gonna need to let me actually put it here in terms of the three things. You see, you're gonna need to put where you're adding up, where you're starting. So clearly we're starting from the first term, and then you're gonna need to put where you're ending up. So we need to find out what term this is, and then here you need to put your formula. The formula seems like the easiest thing to put, because your formula seems to be let's see, you have to get something with you have to look at what is happening on the number side. On the number side, you can clearly see it is just an arithmetic sequence. There's 17, 20, 23, going on and on and on. So you have to work out a formula for the numbers. And then on the P, you can clearly see the number. This is the sequence you can use. The 8 up there, you see, and that's also an arithmetic sequence. 8, 9, 10. You see, just adding by 1 every time. Here you can also see the 15 part. That is also an arithmetic sequence. It's just 15 and it's just decreasing by 1 every time. So this is like actually quite simple, because all you have to do is to work out 3 different formulas and then merge them together. So for the yellow, which is like the 17 and everything, all you're gonna do is, you see there's 17 here. Hey, let me make this bigger, bro. Come on now. Come on now. There's like 17, 20, and 23. 17, 20, 23, going on and on and on. So here's a general term. Remember, Tn is equal to A plus N minus 1D. Let's see here. A is 17, right? So it's like 17. N, what you got at N? N is N, you know. D is like plus 3 every time. So the best that is happening here is just 17 plus 3n minus 3. This is like 3n plus 14. Yeah, man. So this is for the yellow. This is what you're going to throw in for the yellow part. Let's do something for the what? We are said we are going to color code it. So we're going to need to work on the like pink. On the pink, it's 8, 9, and 10. So it's like 8, 9, and 10. So I mean, like, come on, this is not so bad. Tn is equal to A is 8, N is N, because we're trying to work out the general term. Value of D is just a 1, you see. So it's like 1 times N, 1 times that. So here it's going to be 8 plus N minus 1 here. And then what you got? 8 minus 1, that's like 7. 7 plus N is for the pink. And then you want to move on to the green. I will stop saying R. I really should, eh? So it's like 15 here, 14, 13. But it just feels so good on the tongue, you know, like R do this, R do that. Let's see. Tn is equal to, let's see, A is like 15. N is N. Our D here is just the 1 as well. So here this is just going to be 15. And then this is going to be plus N minus 1. This is just 14 plus N. Okay, so that's that. It's quite easy now. You're just going to take the yellow, take the pink, and take the green and put them together here. And this is how you do it. So for the yellow, which is going to, remember, you're going to need to put your formula here for what is generating this sequence. So for the yellow part, you can clearly see it's being generated by this. So you're going to put here 3n plus 14, because that's just the number part of it. And then you can see there's a p in each of them. So obviously, I mean, like, where you see p in each of them, you can just put p, there's the base. And then an exponent of p is being generated by the pink part, which is given by this formula. So you can just put here to the power of 7 plus n. And then for the k, you do the same thing. You see, k is just there everywhere. So you're just going to put a k here as the base. Remember, this is not a a floating number, it's a base also, so let me put it at the same level as the p there, and then this k put you in the same level as the p, maybe. And then what's happening here? K is like, then you're 14 plus 4 there, 14 plus n, you mean. So this is your formula, you see, nice and easy. So even with your formula, you can use that to find out where you're ending up, because I mean, like here you can easily just put here for n, you can easily just put here n is equal to 1, so that you know that you start from 1. You see, if you throw 1 in there, you're gonna have 1 times 3, which is like 3, and then plus 14, that's a 17. If you throw in 1 in there, you're gonna get 8. If you throw 1 there, you're gonna get a 15. So let's see what we need to do to get this, you see, so that we can see what term this is, to find out how many terms we have added up. Now you can actually do this using any of your formulas, because you want to see something like, for example, if you're using the pink, you want to work out where 20 would come out if you use this. For the numbers, you just want to use this formula and find out where 53 would come out. So let's just use the numbers, because I think that's like the easiest thing to use. So we want to see which term gives us 53, so that we know how many terms we need to add up, you see, because we're starting from 1 anyways. So here, let's see, working out a value for n, it's going to be like 53 minus 14. Yo, mental math, I always subtract 10 first. That's going to give us 43, and then minus 3, that's like 40, and then minus 1, that's like 39. Woo! Mental math is very dangerous. I do not recommend. So just use the calculator here before we mess up nicely. Yeah? You know, when you're flowing, don't do anything to jeopardize your flow. So let me just see here. I'm just seeing the calculator so that I do not auto mess up, because I don't want to mess up me. Calculator. Oh wait, hold on. My calculator is doing funny business for such a simple calculation. Come on, man. 53 minus 14. Hi, man. 53 minus 14. 39. Nice. Well done. Wait. Well done. Oh, I forgot this. Hey. I will go back to it. Let's see here. What I need. Yeah, this is correct. So, divide both sides by 3 here. What does this give us? It's not like 13. Yeah, I think so. The way I'm like, I think so. I'm like, my guy, you're thinking so. You're not serious. So n is 13, so you're obviously going to add up terms until like the 13th one. Whew, yeah, this is crazy zoo. So this is basically what you can put here as your answer. This is something that they will mark as correct, but the one for the green is, I'm not very happy about the green. Let me just check the green nicely, because the green don't look very nice, you know. What does the green look like? That is what K is like 15. Oh, it's decreasing 15. Oh yeah, here I made a mistake. Oh my goodness. And you probably saw it early, because it's a minus D, man. Come on, bro. Man. Let me actually use a different color to show that the boy had made a mistake. And you see, it's not edited, so that you can see the blunder. And probably have some comments there like, bro, you made a mistake. It's okay. This is gonna give us negative n, then like a plus 1 over there, and then this is gonna be like 15 plus 1, that's like a 16. So this is 16 minus n. So let me change this thing here quickly. 16 minus n is what we have. Minus n, yeah. 16 minus n. There you are go. So everything here looks all nice and dandy. This kind of a question, it looks like you can obviously go through it again if it is not making sense, but I think everything here was like nice and super clear. So this is how you would have written it in Sigma notation. Let us move on. Question number 4. Yeah, let us do this, but before we do that, I need to like plug this thing here, because it is important to see, because you watching this video, it is good, because look what you have bumped into here. Very nice, very nice stuff. Anyways, so this is from the course platform. You see everything on the course platform 50% off if you use this code. Yeah, so like at checkout, just put this code. For it says here question 4, right? The graphs of f of x is equal to this, and then it says, but then this was, man, I feel like never mind, let me just carry on. It says here the graphs of this and this are sketched below. Okay, so you have what? You have a parabola here and you have a hyperbola. The equation of the parabola is given, so yeah, that's nicer. It says B is the y-intercept of f, and then it says A is the turning point of f, and then it says the vertical asymptote of G forms the line of symmetry of f. So this is quite important. The vertical asymptote of G, yes, vertical asymptote, which is the one from the top going to the bottom. This is the axis of symmetry of the parabola, meaning this is the middle of your parabola, meaning it is in the middle of your two x-intercepts, meaning it passes through the x value of the turning point. Well, it basically just passes through the turning point in general. So much information just by them saying that. Then here they said the horizontal asymptote of G cuts through the y-axis at B. Okay, so B, we already know what B is. Oh, excuse me, it's a -4. The reason why we know it's a -4 is because B is the y-intercept of the parabola, of which, remember, this shows you the y-intercept of the parabola. So the y-intercept of the parabola here, we can see it is a -4. Nice, very nice. So much information. For 3 easy marks here, they said we should get the coordinates of A, the turning point of F. Getting the turning points of any graph is the easiest thing that you ever have to do, because you can just use the first derivative. Even though it's a parabola, yes, you can also still just use the first derivative. Let me just write this out. -x squared minus 6x minus 4. So getting the turning point, all you have to do is you have to differentiate once and then equate to 0. So differentiating once, so let us see what we get when you differentiate once. Differentiated once here, so let's equate this to 0 so that we can solve for x to find the x value of the turning point. You are going to get x is equal to -3, and let's see, yeah, that kind of matches up. It's on the left side. So this is telling you that the x value of your turning point is where x is a -3. To get the y value of the turning point, you can just throw this into the original graph, because remember, the original graph is the one that gives you coordinates. This graph gives you gradient, or it gives you an x value where a specific gradient is like occurring, or it gives you the specific x value of a specific gradient. Like here, for a turning point, we always know that the gradient there is a 0. That's why where gradient is, we threw 0 there and worked out the x value where that gradient is a 0. So here now we're saying we know that the turning point is where x is a -3. So in the normal equation, we're going to throw in -3 where x is, so that we can find out the y value of other turning point. All this is stuff that is covered on the main channel, Bright Young Brains. That is also the main channel on the YouTube. You can check it out. It is like small clip tutorials in like a different format and all that. And then you also have the course platform and like the website and everything down here. But all this, let's see, this is going to be 9 plus 18, which is like 27, minus 4, which is like 23. This is good. So this is the coordinate, right? A here, x is a -3. Your y value is like a 23. Hey, what is going on here? You don't know how to write a bracket no more. What had happened to you to not be able to write the bracket? Anyways, that's that. Nothing crazy here, nothing major. You just write it and you keep on moving forward, you know. But I feel like I made a mistake, a big one here. Let me check my calculations again. Yeah, it's gonna be and the negative, that's a plus. Oh, I forgot to put the negative in front. Yo. Yeah, mistakes galore today. It's sad, Shem. It's sad. Shem. The boy is making the mistakes. Yeah, he's swimming in them. Yo. It's gonna be a 5. It's gonna be a 5 because it's like negative 9 plus 18. That's a 9, and then minus 4. That's 5. Whew. Yeah, ne? He's good. 1 mark here. Get the coordinates of B. Oh, we already did. B, x value is a 0, and then the y value is like a negative 4 because it's like straightforward. Determine the x-intercepts of f. X-intercepts of f. We just need to equate our equation to 0, my guy. So we just need to take this, make it equal to 0, and you can just use the quadratic formula if you want, or you can just factorize. But if it usually when this is a negative, me I'm scared. I just use the quadratic formula immediately, just immediately. I don't even bother, because here negative b plus x is equal to minus b. No, what you doing, bruh? Yeah, it's negative b plus minus b squared minus 4ac. I was already getting confused, like this boy getting confused by something that's on the formula sheet. Come on now. So here x is equal to minus b plus minus b squared. What is b? B is like negative 6. Yeah. Okay, so as of this recording, it is pretty late in the evening, and hey, my brain is still working, but I'm pretty sure you can see that yeah, it's glitching here and there, just glitching here, glitching there, but it's still there, the brain is still there, the brain is still bright. The brain is definitely still young, forever young, baba. So x here, let's see what is gonna be in the calculator. Let's see in the calculator. Let's put everything in the calculator. In our calculator, we are getting an x value. Oh, 2 x values. Oh, yeah, here you could not have used your head, Yeah, So this is like negative 0.76. Let's write that down. Negative 0.76. or x is equal to. But then this doesn't make any sense though, because okay, no, it does. It just means x. It just means negative 3 is in the middle of these two weird numbers, which is possible, definitely possible. So these are the x values of the. So if you're gonna give them as coordinates, now you have to make sure that you write them as coordinates, because when they ask for the x-intercepts, they want you to give them as coordinates. So let's see here, negative 0.76 coordinate 0, or negative 5.24 coordinate 0. These are your 2 x-intercepts. Okay, write down the equation of g. What is g? Is g the hyperbola? Hyperpolar. Okay, getting the equation of g is quite simple, because if you've gone through multiple papers on this channel, then yeah, you already know what to do, But let's see here. Let's just cut this thing. So the idea with getting the equation of g is that you just have to get your asymptotes, because I'm like, a is already given. Your asymptotes, I feel like it's so easy, this one. How many marks? 2 on DC. Yeah, that's why. Because look, you always need to put your x asymptote here. Like whatever your x asymptote is, you always put it here. Because what I mean is, you see here, your x asymptote is passing through where x is like a negative 3. Rule of thumb is, whatever you see on the Cartesian plane, on the equation, you always put it as the opposite. So far, that's for x only. See, this is going to be x minus 3. No, x plus 3, because on the Cartesian plane, it's a minus 3. Because it's a minus 3 here, we have to put a plus 3 over there. That's for a hyperbola. And then with the asymptote for y, you take it as it is. Because it's a minus 4 here you do have to just put a minus 4. It's only x where you swap around. But then for y, you put it as it is. And then there you have your equation. 4.5. Determine the equation of the axis of symmetry of G that has a positive gradient. So Yeah, you know, if you go through things like the functions and graphs course, like if you go through it nicely, these questions are all really easy. Like, I really don't want to lie to you. I really don't gain anything by lying to you, to be honest. But let me show you. So here they said you should get the equation of the axis of symmetry of G that has a positive gradient. What they mean is, if you look at your image here, this hyperbola where your asymptotes meet, this point is very important, you see, because this is the point where your axis of symmetry is passed. You always have two of them, one with a positive gradient, which is going to be equal to positive 1, and then you always have another one that has a gradient of like negative 1, always and forever. You see, the gradients won't be like anything else. Here the gradient will be equal to like negative 1. So this one that has a positive gradient, all you have to remember is its equation is always y is equal to x plus c, showing that the gradient is always a positive there. Now for you to find the y-intercept, you always have to use a point that the graph passes through, and the graph always passes through the point where your asymptotes meet. So for you to find the equation here, you can even just write it like this. Remember the equation of a straight line, y minus y1 is equal to m, and then x minus x1. For our straight line, gradient is a 1, and then let's put in a coordinate here that the graph passes through. So the coordinate that we have is -3 and -4. So for x, you remember here, if you put a -3 here, this is going to be a plus. If you put a -4 here, it's going to be a plus. So the equation is just bro, what's going on? It's going to be x plus 3 here. Y is going to be equal to this, goes over to the left, it's going to be x minus 1. There you go. Very nice. We love it. We love it. So that's the equation of the axis of symmetry that has a positive gradient. Now if you look nicely, it does look like this is going to be like a -1. So it's all good. Moving on. 5 marks. Ooh, 5 marks. I feel like this is the first 5-mark question today, right? Maybe I forgot. I don't know. Determine the coordinates of the intersection of the axis of symmetry, which is determined in 4.5 and G if x is bigger than -3. So this being a 5-mark question, it just means you have to check all these boxes. Firstly, determine the coordinates. So you want to work out coordinates. That's the big picture. You have to work out coordinates of the intersection of the axis of symmetry. So the axis of symmetry that we worked out is x, is this one here. This is the equation of the axis of symmetry that we worked out. Now if you look at the way I'm analyzing this question, this is exactly what you want to do. We read the question and now we're just pinpointing what is important, you see, because you just need to don't think of answering a question all at once. Just break it down. Like now, you see, we know the axis of symmetry that they're referring to. We need to work out the point of intersection of this axis of symmetry with the graph of G. So the graph of G, where is its equation? G, we worked it out to be 2 with x plus 3 here, and then minus 4. The axis of symmetry that we worked out now is this one. They literally want us to work out where these two meet each other. But then apart from us working out where they meet each other, they want us to get the point where they meet each other only where x is above -3. So meaning we should get the point of intersection on the right hand side here of our sketch. You see the right hand side of like our asymptote, of which if you look nicely, I mean, like, it's so clear. There is one point where our axis of symmetry here is touching the graph of G, and it's like somewhere there. So we can already use that as a way to like see what kind of answer we should get. Just by looking at this, our x value should be close to this x value. Our y value should be below -1. So let's do it. Let us all do it. Let us all do it. So here we already have a y value. This is also a y value. So we can just equate the two equations to each other. Let's see here. This is equal to x minus 1. Okay, x minus 1 over there. Take everything. What you're going to take this over to the other side. This is going to be x. x plus, this is going to be negative 1 plus 4. So it's like going to be like a positive 3, right? And then here you have like 2 with x plus 3 there. And then you can cross multiply, you know. 1 times this is a 2. This times this is like x plus 3, x plus 3. Nice, nice. So let's see here. This is going to be like 2. X times x is like x squared. And then like 6. Hey, you're doing the whole 6 thing again. Yeah, you write it out, Baba. I know it's a 6, but now I'm scared. Let's see here. This is going to be 2 is equal to this plus 6x plus 9. If the 2 goes over, then we're going to get a 7 over there, you know. Factors of 7 that give us a 6. This looks like we can factorize nicely here. So nicely. X with another x. Factors of 7 that can give us a 6. That's just plainly 6 and 1. But then to get a positive 7, it has to be either 2 negatives or 2 pluses. So this is quite tricky. No. This is not what. Factors of 7 that give us a 6. It's 7 and 1, my bro. Now, 7 being a plus means that these two signs have to be the same. Because a minus and a minus gives a plus and a plus give a plus. So to get, oh no, snap. Yo, I feel like I'm getting confused here. Hey. This is not working. Let's use the quadratic formula. Yeah, minus b plus minus b squared minus 4ac all over 2a, x is equal to minus b plus minus b squared minus 4a, c is like a 7, and then a here is like a 1. Okay, x is equal to something, or x is equal to something else. Let's put all this in the calculator. Let's see what it gives us. In the calculator. Please help us, calculator. Please. Help us. Help us, calculator. Please. Yeah, so this calculator don't want to do the things, but we are going to force it. Anyways, x here is going to be negative 1.59. Negative 1.59. Or the other one there is like negative 4.41. But then remember they said our x value has to be above negative 3. So automatically here you have to disregard one of these answers, which is like this one. So here you have to take this coordinate here. You see negative 1 point. Write it nicely. Whew. Negative 1.59. So we're going to take negative 1.59 and get a corresponding y value. So from here, let's put information into our equation. Negative 1.59 minus 1, that's going to be negative 2.59. Okay, that looks correct because remember we said that our y value has to be below negative 2, and it is, you see. The y value here is below. No, we said it's going to need to be below negative 1. So negative 1 is like somewhere there. So down here, it's definitely somewhere around negative 2, which is okay. Whew, that's how you work out a question like this. This is the y and the x. So you have to give it as a coordinate, right? So let's just say here, therefore, negative 1.59, coordinate negative 2.59. That's the way. I like it. 4.7. Determine the equation of m, the tangent 2g, with the point where they touch the Wait, determine the equation of m, the tangent to g, with the point where they touch the intercept calculated here. Okay, that's not so bad. So firstly, you have to break it down. A tangent is just a straight line graph, mx plus c. You see, but then they said determine the equation m. So you can actually, you can just use different variables here. You see, mx, let's make it a straight line format. You see, kx plus c. I'm trying to not just use m again because you see, this just said it should be equation m. This is just a straight line graph. You see, don't worry about what I've just written down here. it's still just a straight line graph. You see, y is equal to mx plus c. I've just written it out with like different variables here. Now the good news is the point of contact between this tangent and our graph is this point that we worked out here. So let me just get this point here and copy it so that we can see it. Now from the tutorials on like the main channel, getting an equation of a tangent to a curve is something that we have covered so often, and even in the functions and graphs course it's like covered extensively. So a tangent and a curve have the same gradient where they meet. That's how you're going to get k, by using the gradient at the point of contact. So the gradient at this point, all you need is the x value of the point of contact, because you want to get the gradient at this x value. That's the gradient of your tangent. Now to get the gradient at this point, you need the gradient of the curve at that specific spot. So we need the gradient equation of our hyperbola. So with our hyperbola, let us get the gradient equation of our hyperbola. So obviously with our hyperbola, we have to differentiate. Oh, but how do we differentiate a hyperbola that looks like this? Uh-oh. I feel like we are about to get... Oh no, it's about to get real tricky. Let me just see here. Determine the equation m, the tangent to g, with the point... Wait, determine the equation of m, the tangent to g, with the point... Oh, determine the equation of m, the tangent to g, with the point where they touch the intercept calculated in 4.6. Yo, gradient equation of a g is the hyperbola. Yeah, g is the hyperbola. Yo, nah, yes, man. Oh, I'm going to finesse this question so good. And after finessing it so good, yeah, but my logic seems to be working out, because I'm looking at this and I'm thinking to myself, the gradient of this line here, of this tangent is going to look like this. Now you have to remember that a tangent like this will always be parallel to your negative axis of symmetry, meaning it will always have a gradient of like -1. It has no choice but to have a gradient of like -1. It's always like it's basically a law, you know. So with where is it now? Here. So already here we cannot differentiate in grade 12, but then what we already know is that the gradient here is just automatically a -1 because of what we just explained. So here so far we can say here y minus y1 is equal to -1, and then x minus x1. Now we need to like throw everything into, we need to now throw in a coordinate that the tangent passes through, of which we have it. So we have the negative this for -2 point something for y. So we have to put it as a positive here. And then we have like -1 point something there. We have to put it as a positive here. Let's just simplify. Y is equal to everything on one side, right? So it's like, what you got? Hi Bowman, what you get? What you getting? It's like -x here minus 1.59 minus 2.59. This is giving us y is equal to -x, and then -3.59. Wow, this looks so weird, right? It looks so weird as a final answer, but this is the final answer we're getting, man. Like, but no, I made a mistake. Negative that minus that, bro, that's gonna be 4 point something, my guy. Use the calculator. You see, you not using the calculator, making these dumb mistakes. Nah, you come on, maybe, come on. Okay, this is going to be the equation of the tangent. You see, nothing too crazy. We just had to think outside the box. So that is why I think also, you see, making these kinds of sketches on your answer sheet, it's super important, because you're gonna save yourself, man. 4.8 for 2 marks. says the following: for which values of x will this multiplied by that be bigger or equal to 0? So you have to remember that the left portion here is talking about y values. The right portion here is talking about gradient. And this is dealing with the same graph. You see, for the same graph you have to deal with its y values and you have to deal with its gradients, because remember there's different gradients at different points. So they're saying if you take the y values and you multiply the gradients at specific points, where will the left side be a positive number? What I've just said now, if it's not very clear, then it means you need to go through the playlist on the main channel, Bright Young Brains on YouTube. Just search Bright Young Brains on YouTube, and then you need to look for the inequalities playlist, you see, because it will make better sense there. Because remember, the other channel is the one where it's like small tutorials and stuff like that. Here you should be going through these papers after your theory has been done. You have been going through the courses also, and you know your work, so that all this is making better sense. So the question, this kind of a question requires you to use your sketch, because for this left side to be a positive number, then it just means that both these two have to be a positive, or both of these two have to be a negative. And then obviously for them to be equal to 0, then only one of them has to be equal to 0 at a time, you see. So this can be a 0, or the other one can be a 0. You see, for this scenario, you're definitely going to have a value that is equal to 0. But then don't worry about the pink, just worry about this, you see. So what I mean is, if you're going to work out where the left side is bigger or equal to 0, focus on you looking for x values where this will be a negative y value while this has a negative gradient. And you have to look for cases where this has positive y values while it has a positive gradient. So with looking at the image, it becomes a bit easier to analyze, because if you look at your image, your graph of f is the parabola here. Now this parabola, you want a portion where you have y values while having positive gradients, and you want negative gradients while having negative y values. So let me just draw a rough sketch of what we have. We have a negative parabola that looks like this. With our negative parabola, we have the axis of symmetry in the middle here. This is where x is a 3, or negative 3 rather. Now the big idea here is, it's clear to see that on the left side here, though somewhere, let me just draw our Cartesian plane. Somewhere here we have our Cartesian plane, right? The x value here is like negative what? Let's go to it. This question is not so intricate, but if it is, you see, it needs to go through the courses. This is like negative 5.24. Let's put here in white so that it like stands out. Negative 5.24, and then here negative 0.76. So the big idea here is that what we need to know is everything on the left, you have negative gradients. You see, no, positive, because you're going up here. Your y values here are getting higher and higher and higher. You see, as you're moving from left to right, your y values are getting higher and higher and higher and higher and higher until there. So it means that you have positive gradients here. And then after the turning point, your y values are decreasing. So here you have like a negative gradient. You have negative gradients everywhere here. So we said we want a portion where we have positive y values together with positive gradients, and we want a portion where we have negative y values together with negative gradients, because here you see you have positive y values here because they are above the x-axis, and there's a positive gradient here. So these are the x values that satisfy your answer. And then here also we can see that you have a negative you have negative gradients here, and your y values are also negative. So the x values that satisfy our equation here, it's going to be from negative 5.24 until negative 3, and then it's going to be from negative 0.76 all the way to infinity. So in terms of your answer, you're going to need to say x has to be bigger than this number here, technically bigger or equal to this number, bigger or equal to this, right? But then your x values need to be smaller than smaller or equal to negative 3. The reason we're saying smaller or equal to negative 3 is because at negative 3 the gradient is a 0. So if one of these are a 0, that's good. At negative 5.24 the y value here is a 0, so that's also okay, because either one of these can also be a 0, because that satisfies our inequality. So this forms one of our answers. Our second answer obviously comes from this second portion here. Let me actually color code it differently. Let me maybe use not a white, bro, come on, let me maybe use a yellow. See this part here, your x values are obviously bigger or equal to negative 0.76, because from negative 0.76 all the way to positive infinity, you're going to get a gradient that's a negative while having negative y values. So that is all you have to do for this question. Again, this is all in the functions and graphs course, and as mentioned, as long as you're watching this video, you can always hit me up for this 50% discount code in case it has changed or whatever. But you can try this out at checkout, see if the price adjusts, and then make the purchase. Or you can just hit me up on IG if you have any questions. Question 5, more functions, because I mean, like, paper 1 is definitely all about functions, you know. That's why you have to make sure that your functions are on par before you do any funny business. But yeah, I feel like I should just do this, you know, so that people don't miss this big opportunity. Oh, come on. No, I wanted to copy the discount code thing. Come on, man. Like, snap. Come on. I feel like I'm wasting time. You can always skip ahead, I guess. But yeah, the purpose of... Wait, am I saying? Where is it? Where is this thing here? I need to make sure I copy this as often as I can, so that when I start with like a new portion, I can always like paste it, you know, and plug the peoples. Because I mean, like, if you're watching this video, then you're obviously like the real OG, man, you know, and you deserve to know when there's like a promo going on and when there's like stuff that are nice. So 50% off everything on the course platform. Very rare stuff going on. I mean, like, hardly ever give so much of a discount, but it is what it is. So anyways, question 5 here says, given this information, this is a straight line graph. You're looking at it from negative 4 to like positive 6. Okay, that's quite interesting. Okay, then they said here you have an exponential graph. Oh, why am I yawning? Why am I yawning so much? Yawning feels good though. So wasn't about to interrupt that for nobody. Excuse me though. I guess maybe yawning rude. Hey, me angas, man. But yeah, it is what it is. So let's see. What else? Oh, we have an exponential graph and a straight line graph, and then they said Q is that point there. It is a point on H. Okay, that's very nice. Very nice. For 2 marks, determine the x-intercept of K. X-intercept of K. This is the x-intercept of K. Well, that's quite easy because the y value here is a 0. You see, it's nowhere up, it's nowhere down. So the y value here is a 0. So on the left of the equation, we can just put a 0 there because the y value is a 0. And then we can just solve for x. Such basic questions. I was really thinking the Northwest paper was like kind of hard, but yeah, I'm disappointed. I'm so disappointed. And I'm sorry. I wanted to do like a difficult paper, but this one. It's just biasing this one. So here, remember, you can divide by 2/3 on both sides. You see, so don't be afraid to divide by a fraction. You see, and cancel. It's just normal, you know. So yeah, this is gonna be like a 3. Is it going to be a 3? I hope so, because I mean, like, you know. No, man, this is 4.5, bruh. You. Just use the calculator. Should I don't need the calculator for this, but I suggest you do use a calculator in the exam, because you're gonna end up making like really dumb mistakes, and you really don't want that. This is 4.5, or 9/2 rather. So so here you're gonna say therefore 4.5 coordinate 0, because they ask for the x-intercept, so you have to give it as a coordinate. If you leave it like this, I mean, you could be like, and then they'll just give you your mark. Anyways, determine the domain of the inverse of k. So you have to be careful here, because this is the inverse of k, meaning it's the inverse of the straight line graph. So the straight line graph, let us see it quickly. Come on, straight line graph, let us see you. We want to get your inverse. So before we can get this inverse, we obviously need to just want to copy this thing here. -2/3x plus 3, right? Let me copy this. Let's see here. What now? Let me paste this thing here. Make this a bit bigger. There we are. Go. So this is what k of x looks like, you see. Let me just write it as y. So getting the inverse means x and y swap. So you can even show it here. X becomes y. No. Come on, man. Y becomes y. What is that, man? What is that? It's business. I did business. No, that is not business, my guy. That is just fraud, you know. Not fraud, fraud. Yeah, never mind. I will stop. So what is next? Yeah, x becomes y, y becomes x. So it's like -2/y there plus 3. Now we need to make y the subject of the formula. So this has to go over. Whoa. Stop. Scratch everything out. I was overshooting the runway there so hard. It's just a 2-mark question. They asked for the domain of the inverse. I was forgetting one basic rule, and this is what the basic rule is. The domain of the inverse is the range of the original graph, you see. And the range of the original graph is the domain of the inverse, because inverse just swaps the properties of x with the properties of y of a specific graph. So that's why this is just a 2-mark question. So here, let's get the range of the original graph. So let me say here, range of original graph is the domain of the inverse. You see? Okay, so let's just get the range of our exponential graph here. So the range of our exponential graph, judging from the equation, we can clearly see that the asymptote is where y is at 0, because you see it's cutting the y-axis at 0 over there. So the range here, it is just y is bigger than 0. That's the range of the original graph. So the domain of the inverse will then need to be x is bigger than 0. You see, because remember we said the range of the original graph is the domain of the inverse. So remember, domain, you write it as x. You see, so that's why here we just put x is bigger than 0, because the range of the original graph is y is bigger than 0. Very nice. So I was about to do some funny stuff here. Busy getting inverse. Determine the inverse of h. What is h? H is the exponent. Exponent. X is this equation, 2 to the power of -x. Here we can do that shandies, you know. X becomes y, y becomes x. So this is like x is equal to the power of negative y. Now whenever you work with logs, it will be because you want to isolate an exponent. So you isolate the exponent because that's what you want to do. And then on the left side, you can put log. The base of the exponent becomes the base of the log. Whatever this value is just goes there. Obviously, y has to be alone, so you have to divide by a negative, you see. So this is going to be like log 2 with x with a negative over there. And then they did say we should write it as this thing here. So you can then say, therefore, this is equal to negative log with a 2 and an x. Flowing, eh? Just flowing, J. 3 marks. 5.4 says we should give the coordinates of the x-intercept of the inverse. So the x-intercept of the inverse. The good news is the x-intercept of the inverse is the y-intercept of the original one. Because remember, they always just swap around. So here, this is the y-intercept of the original graph. The y-intercept of the original graph, I mean, just from basic knowledge, the y-intercept here of the original one, right? We know x is a 0. So you can put x as a 0 there. It's just a 1, you know. So you know that the y-intercept here is a 1. Now here, this we're talking about the inverse. They want you to get the x-intercept of the inverse. So here you can clearly say x. This is a side note for like the tutorial that we're having. You don't have to write this in the exam. I'm just trying to write it so that you know where we're getting our answer from. X-intercept is the y-intercept of the original. I think what this paper does is it gives you a good idea of like what inverse really does. It just swaps around properties of x with y. So because our y-intercept is 0 coordinate 1, our x-intercept of the inverse is just going to be this swapped around, you see. So hold on. So the x-intercept, the x-intercept is going to be 1 coordinate 0, because remember, an x-intercept has a y value of 0 anyway, so you know that this is correct. Because remember, we said for inverse you always swap around properties of x and y. So whatever the y-intercept is of the original one, if you get the inverse of this, the y-intercept here is going to be the x-intercept over this somewhere. I think you'll see it better if they ever ask us to sketch this graph. Since they are not going to ask us to sketch it anyway, let me actually just sketch it so that we can see it nicely, so that our question makes better sense. So if you look at the axis of symmetry here, this is your axis of symmetry, and your inverse graph would go somewhere here. It would be going down like that, and no, my bro, no fam, no. So for you to be able to draw an inverse of a graph, I always say focus on this, focus on this. Now I always say get like a mirror image of those points. So here, this, right, its mirror point would have been like somewhere over there, and then this, its mirror point would have been like somewhere over there. So you now know that you have an arrow here. Then now you know your inverse would come out something like this. Come out something like this. Hey, come on, man. Ooh, that's not so bad. Nice, very nice. That's the way. I like it. This is what the inverse looks like, you see, and you can clearly see the y-intercept here becomes the x-intercept over there. You see, x is 1, y is a 0. See, the x and y just swap around. The same way that domain and range, the x and y just swap around. Woo! Nice, man. Very nice. So let me just make sure I label this as the inverser for you. I'm sorry if I seem like I'm rushing. I'm so sorry. So remember, I feel like the emphasis is that if things are still getting over your head, then you really need to take the time to learn the content, you see. so that past papers make better sense to you. And as I said in this paper, 50% discount code BYB50. It's almost like a secret code that some people know, some people don't. So if you know, you know. Let's see here, what's next. Okay, so 5.5 it's a 2-mark question only, but I think for the sake of proper explanation, I need the sketch and I should not take any shortcuts. The idea is they're asking you for which values of x is the inverse below 0. For which values of x does the inverse have y values that are below 0? So the easiest thing you can do for yourself is to visualize the graph of the inverse. You see, you can actually draw it for yourself. And the easiest way to do that is, here you already know this is like 4.5, which is like 9/2 coordinate 0. This is one coordinate of the original graph. This is just the y-intercept. The y-intercept, remember, you can get it from the equation of the graph, of which where is that y-intercept? How? Come on, man, come on now. Bro, where's the equation of the thing now? I feel like I lost it there. The equation of the straight line, remember, the y-intercept is like a +3 over there. You see, the y-intercept is a +3. So automatically, you know that this is like 0 coordinate 3. These are the coordinates of the original graph. Now, excuse me, the coordinates of the inverse, like the y-intercept of the y-intercept of the inverse and the x-intercept of the inverse, is just going to be these swapped around. Like, for example, the x-intercept is going to be this value, like it's going to be 3 coordinate 0, you see, because this is going to be swapped around. 3 coordinate 0, this is going to be the x-intercept. The y-intercept is going to be this swapped around. That's for the inverse, meaning that this is going to be like somewhere over there. You see, x is going to be a 0, but then y is going to be 9/2. You see, this swapped around is that, this swapped around is this over here. Let me actually move it a bit, you know, so that it's at least proportional and not too far. So let's do that. Yeah, somewhere there. So let's connect these 2 points here and see what they end up looking like. Something like that. Oh, yeah, ne? Let's finish this real nice. Let's give it some. So the idea is, you see this blue line here, right? Let's actually extend it until somewhere there, so that it at least matches with that one. You see, because they say that they gave us a domain of like somewhere, I think -4 until like 6 or something. So this point here, let's also maybe extend it until like somewhere there, so that it's like aligned with that. You see, so what they told us here, you can see it's a closed circle here, so this is clearly at like -4. This is clearly at like +6, according to like what they told us right in the beginning here. You see, from -4, oh yeah, -4 is included, 6 is not. So the big idea here is, you just want to think to yourself, they say it here, for which values of x will the inverse have y values that are below 0? So clearly you can see it has y values that are below 0, starting from here. You see, starting from where x is a +3. You see where 3 is not included, because at 3 it's equal to 0, not below 0. So it's going to be your x values from 3 all the way until yeah, this is actually quite crazy, right? Because you may be thinking to yourself, then shouldn't it be like from 3 all the way to like 6? Because I mean, let's see here, for which values of x is the inverse below 0? Yeah, this is 3 until 6. Why am I being so hesitant? It's just a 2-mark question. I mean, like, a 2-mark question, we should not overthink anything, you know. So yeah, this answer, it's gonna be from 3 all the way until like 6, because yeah, there's nothing else here. Just go check the question again. For which values of the x, and oh, wait a minute, yeah, until 6, but then 6 is not going to be included. Yeah, let me just put this here. This is going to be like a 6, right? So we're going to need to say our x values, x needs to be, let me write it in red so that it like matches up, you know. X needs to be bigger than 3, or x needs to be smaller than 6, because 6 is not included in our original domain that they gave to us. At 3 specifically, the graph is equal to 0, not below 0. So these are going to be your true answers. And then let us just move on now. For 5.6, yeah, 5.6, we have to be like super duper careful, or not super duper careful per se, but just careful, I guess, because it's a 3-mark question there. This 3-mark question says, what does it say? What is this thing here? How did it get here? The 3-mark question, the 3-mark question here says, if k of x is the gradient equation, or yeah, if k of x is a gradient equation where q is the function defined from this to that, draw a neat sketch of q, clearly show the x values of the turning points and the end points. Let me read that again. What they're saying is k is a straight line, but then they're saying k is showing the first derivative of q, and then they said q is a function from -4 to +6. They said we should draw a neat sketch of like the function. Well, the big idea here is, already if you have seen from like the tutorials on the main channel, any straight line graph, if the straight line graph is a first derivative, then it means that its original graph is a parabola. Because if you start off with a parabola, right, which is what q of x is, a parabola, if you differentiate a parabola, you will always end up with a straight line graph. You see this differentiated is just 2ax plus b, you see, which is a straight line graph. Now the big idea is, let me just write this nicely. Come on, man, do this here, do that there, yada yada yada. So whatever straight line graph we're dealing with here, which is k of x, this straight line graph is the first derivative of a parabola. Now our parabola, you have to remember that if this is a straight line graph, right, the y values of this straight line graph would be the gradients of our parabola. Let me say that again. Here we can clearly see that this forms a straight line graph. You see the y values of this straight line graph, which is technically k of x in our case, the y values of k of x, we can clearly see those would be the gradients of the parabola. So if we know that the gradients of our parabola is basically making these y values here, it means that we can use these y values here to determine like the different gradients of our parabola and all that. But the easiest thing to do for yourself is, you have to remember that the first derivative of a parabola, even though it's a straight line graph, the straight line graph that you have, the first thing to focus on is what kind of a parabola are we going to have. Are we going to have a smiling parabola, or are we going to have a frowning parabola? Now you can clearly see that from left to right, these y values are decreasing. What this is telling you is, for your parabola, from left to right, you can clearly see that the gradient has to be like decreasing, and then the gradient is going to be equal to 0. And then from 0, you can clearly see that your gradient is also going to be like decreasing some more, going on and on and on. Or rather, what you can think for yourself here is that you can clearly see these are positive y values, right? Positive y values here for your straight line graph mean a positive gradient for your parabola. And then this is telling me that the gradient here is going to be a 0. And remember, a gradient is a 0 at a turning point. And then after this gradient of a 0, this is showing me that you're going to have negative gradients. So automatically you know that you're dealing with a negative parabola where the turning point is at like 4.5. So at 4.5, you know that you have a turning point and you know that your graph is frowning. The reason you know your graph is frowning is because on the left you have positive y values. This means positive gradients. On the right you have negative y values. This means negative gradients. And then this is what your sketch is going to look like. The two things you can show here is the shape and the point where your turning point is. Let's put here 4.5 over there. And all this being said, you can think to yourself, what else can we put in? We can definitely put in the given domain that they told us, you see, because here they told us that on the left it has to end up at like -4, so we have to remove these arrows. -4 is included. On the right they told us that it ends at no, come back, it ends at like 6. So let me just maybe remove this a little bit. And then you may be asking yourself, why did I remove that one a little bit? So 6 here is like not included, so let's put a circle here. You may be asking, why did I move this a bit higher than that one? The reason we did that is, if you look at it from, this is like 4.5 to 6, the x values here are much less than the x values on the left, because here you'd have put in more x values, so your graph would have gone a bit lower. Here it's just a few x values from your turning point, so your graph would not have gone as low as this side, because remember your graph is symmetrical. So here you have only like, this is just 2.4, I mean like 2.5 difference, and then to the left here this is like 8.5 difference, you see. So here you'd have added, you would have put in more x values into your equation, so your graph would have gotten a bit lower there. This is your sketch. It's going to give you 3 marks. This question, to be honest, yeah, I think it's the first difficult one, and the previous one. I feel like this paper is starting to get difficult now, so let us go. Financial maths. We have arrived at financial maths, and I feel like we're almost done now, because it's just financial math left, probability and applications of calculus. Not so bad, because once you've gone through the functions and graphs section, yeah, you're practically done with your paper. The rest is like, okay. Question 3.6 here says, Patrick takes out an annuity that he can live from after he retires in 20 years time. He needs 3 million in his annuity when he retires. The bank gives him an interest rate of 10% per annum compounded monthly. Calculate his monthly installment into the fund if he starts paying immediately, and therefore at the end of each month until his last payment in 20 years time, for 4 marks. So this question here, you have to be careful of the part where they say that he starts paying immediately, and then he also makes payments at the end of every month, because the starting to pay immediately part is important. So let's see, it's money that is his, right? So you're obviously going to use the F formula. He wants to have 3 million at the end of the day. His monthly installments he does not know, but his interest is 10% per annum compounded monthly, so it's 10% over 12. So always remember to put the percentage symbol here if you're not going to write 0.1 or something. And then what else? This N is how many years? They said he wants to do this for 20 years. So it's 20 times 12. The only issue is they said that he starts paying immediately, meaning when he opens the account, he puts money into the account, and then at the end of that first month he puts money again. You see here it says he starts paying immediately and thereafter at the end of each month, because when you open an account, you only have to start funding it 1 month after you have opened it. But then if you open the account and already start to put money in it, then this is your first payment. So when the first month ends, this is already going to be your second payment. So after the 20 years, you see, you would have made 240 payments after every month. I mean, at the end of every month, plus this one payment that you would have made in the beginning. And I'm actually put it this way so that everything is simple. You have to remember that this is like month number 1 that has ended, month number 2, 3, 4, 5 until month number 240. So 240 months have ended, you see, so that's 240 payments. However, you made a payment in the beginning of your installments, you see, so that's going to be that one payment you make here, and then all the payments that you made at the end of each month. That's why here you have to say plus 1, which is going to give you 241. Putting everything into a formula, n is equal to x, and then it's like 1 plus I n minus 1, the whole thing over I. Because we want x, it's easier for us to isolate x first. You're going to multiply by I on both sides. This is what you're gonna have, and then you're gonna just divide by the big bracket. Dividing by the big bracket, you're gonna have 1 plus I here to the power of n minus 1. This is equal to x. So let's just put x on its own. So f here is like 3 million. 1, 2, 3, 1, 2, 3. Interest is like 10% per annum compounded monthly. And then this is like interest is like 10% per annum compounded monthly. In n, what is n? Oh, n is like 241. And then here our value of x. Let's check it out in the calculator. Calculator, please help us, because we cannot help ourselves. You know, we need I don't know, help. X in the calculator, 3,912.89. 3,912.89. Very nice. Nice. We love to see it. 6.2 for 7 marks. Yo. The puppy is dancing, eh? That doll is going to dance. After 20 years, Patrice retires. He decides not to let the 3 million be paid out. Instead, he decides to withdraw monthly amounts of 20,600 at the end of each month. He withdraws his first amount at the end of the 4th month. The interest that he earns over this period is 8% per year, compounded monthly. Well, per annum and per year means the same thing. And then it says here, determine how many months he can continue with this lifestyle. Wow, that's why this is a 7-mark question, because there's a lot of stuff that has to be done here. The first thing is, he decides not to take out the whole thing after 3 years. He wants to leave it in the account so that he can withdraw from it bit by bit. He says here he decides not to let the 3 million be paid out. Instead, he decides to withdraw monthly amounts of like 20,600 at the end of each month. His first withdrawal is he withdraws his first amount at the end of the 4th month. So him withdrawing at the end of the 4th month, we have to be careful, because all it means is he has 3 million in the beginning of the when his 20 years finish, he has 3 million. He leaves the 3 million for 4 months, meaning it gains interest until it's worth a new value. Now this was over 4 months, and the interest rate, they said here, the interest he earns over the period is 8% per annum compounded monthly. Per year, per annum means the same thing. So the interest for those 4 months was just 8%. You see, this is already in months, so you don't have to times by 12. So this is already in months, so you don't have to times by 12. So before you can do anything here about withdrawing whatever, you have to find out how much is in the account after the 4 months before you start withdrawing from there anyways. So here A is going to be equal to 3 million 1 plus interest, which is like 8% over 12 in your calculator, the whole thing to the power 4. Whew, calculator, please help us, because we are in need yet again. So we are back, we are back. We need your help, so please help us. In the calculator, all this is giving you well, the thing is, actually, now that I think of it, here you have to be careful actually, because they said his first amount is at the end of the 4th month. So if he takes out money at the end of the 4th month, it means he only gained before he starts withdrawing it, only 3 months have passed, because it says he wants to take out 20,600 at the end of each month. He withdraws his first amount at the end of the 4th month. Okay, so if he starts withdrawing at the end of the 4th month, it means that he only leaves it for 3 full months, and then on the 4th one he starts withdrawing. So we have to make sure that n is a 3 here. Yeah, that's kind of tricky, huh? Super tricky. So moving on here, for 3 months, the amount that would accumulate would be, the money would go up to like 3,060,000. Wow, that's a lot of money, man. That's a lot of money. 0.89 actually, but it's not a final answer, so you may want to write a few more decimals. Let's do it like that. But 89, that is just, yeah, it's fine. So this is what the guy has after the 3rd month, because the 4th one is going to start taking out from this account. Now the idea is, when someone is going to be taking out money from an account, and you want to work out how long he can take out that money without going broke, you always need to use the P formula, because you almost think of it as an amount that's gaining interest, but you're still reducing it. So that's why you're using the P formula, because that's what the P formula does. You will be using an amount that's like increasing, but at the same time you're decreasing that amount by, like, taking out from it. So with a loan, it would be a matter of you paying that money off, but then in this case, it's this person taking that money, from the bank account. So here it says, yeah, the interest rate that he earns over the period is 8% per annum compounded monthly. Determine how many months he can continue his lifestyle. So his money is only going to be gaining 8% per annum now. So in our P formula, let's see, they said how many months can you live with this lifestyle. So we have to work out n. Working out n, let's just isolate n. Here you can multiply by I on both sides, and then divide by here's what you're going to be left with, this here, so that I don't do too many steps at the same time. Let me see here, negative n, like that. Divide both sides by x. It's going to be pi over x, and then it's like 1 minus 1 plus I, negative n. You want to work out n, remember, so you can just take this thing here. This is a negative, right? It's not good for this thing to be a negative, so let's just take the green part to the left. It becomes a positive, but that doesn't affect the exponent. The exponent does not get affected by moving stuff to the left or to the right. So this becomes a positive value, and then this becomes a negative pi over x. And then want to use logs, right? So here, remember, the negative n, you want to leave it on its own. So I feel like I'm making a mistake here. Did I make a mistake? Please no. Yeah, where's the 1? You see now, Boso, come on, bro, concentrate, man. Come on, my guy. When's in John? The 1 has to stay here. Oh, the 1 has to stay. Yeah, so here the 1 has to stay, ne? This goes over, and then this goes to the other side. You see, it's gonna be like 1 plus I to the power of negative n. And then let's see, here you want n to be on its own, so you're gonna have n on its own. Here you're gonna have logs. The base of the exponent becomes the base of the log, and then this value is all here, 1 minus pi over x. If you divide both sides by a negative, this is going to be a positive number, and then this is going to be a negative. So now we can put in our values and then just work out a value for n, because you can just throw everything at once. You see here, n is going to be equal to negative log the base here, 1 plus I, that's just 8% over 12. The number up here, 1 minus p. P is like 3,060,000 0.889, and then 8% over 12, the whole thing over x. X, remember, he wants to be taking out 20,600 every month. So that is what you're gonna do. I feel like, yeah. Then here your value for n in the calculator, you gotta be careful here. So this is to prevent, decimals and rounding off. So let's just see here what the calculator is gonna give us. So let's see here. Our calculator is giving us 699.54. Oh, from 0.55 actually. 699.54. Let's see here. 55 actually. So this is the amount of months he will survive. So the crazy thing here is, you have to remember that for what they asked, let's see what they asked here. The interest he earns, blah blah blah, determine how many months he can continue with his lifestyle. Well, technically it looks like he can continue for 699 months. Yeah, like I feel like that is going to be as long as he can survive. But obviously with these kinds of questions, it's just always one of those things where whatever answer you're going to give, don't just leave it like that. Remember, this is after the 4 months, this is after the 3 months when his money was sitting, because remember here he retired after 20 years. You see, this question is asking how many months can he continue with his lifestyle. You see, because technically this is 3 months, this is 699 months after the 3 months. So here you have to say 699 plus the 3 months where the money was just sitting. This is going to be 702 months. The 702 is your final answer. If you leave it like this, you'll get 6 marks. You see, so you have to be careful with this kind of a question. It's kind of annoying, but gotta think a bit deeper with these kinds of questions. But this is why, again, you go through these kinds of papers so that you can always make sure you leave your answers fully answered. Whew. Anyways, let us move on to the next question. They said calculate his monthly withdrawal. So his monthly withdrawal, his final withdrawal, is more like the final payment on a loan. You see, the way you work out the final payment on a loan is the way you're going to work out this final withdrawal. And the final payment on a loan has a formula, you see. So final withdrawal here, it has a formula. The formula, it is literally going to be as follows. So write it down. The formula, A minus F, and then 1 plus I. This is going to be the formula for the final payment, of which A, it's just the normal compound interest formula, and then F is just your normal, installments formula for future value annuities formula. So these two formulas, you're just going to combine them, and then you're going to multiply by 1 plus I. So let us do it. So in this case, your value of P is going to be the money in the beginning, the 3 million and something. So where A is, we're going to put the 3 million 3,60,000. It was 3,060,000. Yeah, 3,060,000.889, and then 1 plus interest. Interest was like 0.08, but it's like 8%. I like to write it like this: 8% over 12. And here will always be this without the decimal. You see, that's like super duper important. N will always be that value without the decimal part, because if you put the decimal part there, then you're gonna have a bit of a problem. You're gonna have a bit of a problem. So if you're going to avoid problems, just do the just use what we have just said right now. You see, you're going to use the three what? Come on, bro, say the words. What am I saying now? Hey, yeah, you're just going to use the what you may call the 6.99 part only. You see, just use the 6.99 part. Don't use the decimal part when you throw in a value of n. So 699, not 6.99, bro. 699. I keep writing 0.99. Yeah, ne? Whew. And then you're going to subtract the F1. So monthly withdrawals was like this much. And then interest is still 8% over 12. And then 699 minus 1. Going to close the bracket, the whole thing over the interest. Yeah, it's a huge sum. It's huge sum. I was about to say it's a huge shame, and then I don't know what happened. I don't know what happened to the words. They just disappeared. Make this smaller, move it to the left a bit. Must be nice. So from here you just need to then multiply that 1 plus I value. 1 plus 8% over 12. Okay, let's put all this in the calculator. In the calculator, it's not so big, yeah? It's not so bad actually. The calculator, the final answer is just 11,247.73. Whew, that is a big number. Okay, it's not that big. It's actually quite small. Oh, I forgot to put no. Come on, my bro. No. Hey, Shekes Yamar. Did I make that mistake again somewhere? Yo, good lord. Yes, like 300. I feel like I've been writing the wrong number the whole time. Yeah, because it's like 3,040,000. Yes, man. Yes. 40. Where is the other one? I guess I was just getting lucky, eh? Because they were so small. 40. Hey? Yeah, ne? Yeah, it's deep. It's deep. But anyways, let's just move on, because I think we have explained the bigger portion of this question. We have dealt with the difficult stuff. The difficult stuff has been dealt with. But anyways, let us just move on, because why not? This is the final withdrawal. 5 marks. They said we should determine this value, or the equation of this thing. We should determine the first derivative from first principles. So before using first principles, I like to use the power rule first, so that I know what kind of answer I should get, so that I can use it to just check if I'm correct. Like here, -2 with x is going to be there, and then +7. This is what we should get at the end. So now you can just use the power rule to get the 5 marks, and then use what you wrote up here to just double check. So in terms of first principles, you see, you have to remember that this is the formula. X with f prime is equal to lim h goes to 0, and then this is like x plus h minus f of x, and then the whole thing here is like h. So this here is let's see, what is this gonna be? Like lim h goes to 0. So here, this all it means is you want to, this you can actually usually do first before you like do the rest. It's usually easier. Wherever x is, just throw x plus h in there and then just simplify. So here you're gonna have x plus h squared, and then plus 7, and then x plus h, and then plus 9. If you simplify, you're gonna have negative x squared plus 2xh plus h squared plus 7x plus 7h plus is that a 9? Looks like a 4, my guy. Yeah. Then let's carry on some more. Negative x here squared. Yo, come on, you're multiplying inside, so it's a negative here, so it's like negative 2xh negative h squared plus 7x plus 7h plus 9. Nothing here is a like term, so you just leave it the way it is. But obviously that helps you to then know that this whole thing here is what you should put over here in your calculation. So let me just paste that. Yeah, it's quite long, but let me just shrink it a little bit, and let me just move stuff to the left, because I'm like, we really have so much space and I'm busy here. Busy. So here it's here. So you remember this minus here tells you that everything here has to change. You see, you're gonna have to have a plus, then here you're gonna have to have a negative 7x, then here you're gonna have to have a negative 9. That's like super important. If you don't do that, you're in trouble. Like legit, it's not gonna work out. So here, this, then no, let's use a different color, bruh. Come on. This cancels that, this cancels that, this cancels that. If the canceling doesn't happen, you also know that you've done something wrong. So these are all just, red flags if you don't see yourself doing these things. So anyways, let's see here. This is like plus 7h over h. Let us take out what we have to take out now. We have to take out h as a common factor. So it's like h comes out negative 2x plus h plus 7, and then the whole thing h at the bottom. See, this h cancels this h, and then what you got? Now you see you're left with negative 2x plus the 7 with the h over there. So here let's just do lim h goes to 0, negative 2x plus h plus 7. The moment you throw a 0 there, you can then put your final answer. You see, negative 2x plus 7. Just the way I like it, which is clearly what we had up here. We see. Moving on, what do we need here? You have to differentiate for 3 marks. So differentiating is all about simplifying first, you see, which is what the applications of calculus course basically does. So here, you have differentiating, you have to simplify. So in terms of you simplifying, yeah, let me just plug you real quick so that at least I don't forget to do so, because the applications of calculus course, like the first chapter in the applications of calculus course, is super important for what it is that we're doing now, because being able to differentiate, it's like a huge confidence booster. If a person is able to differentiate properly at any time, you see, it's always going to help them in their grade 12, because at least, oh, come on, bro, what's going on here? Hey, that's fine. So simplifying here, the first thing is you have to remember that as long as you're simplifying, you have to write f of x in the left, or you have to make sure you don't put f prime here. So simplifying this, you can take it up. It's going to be 4x with a negative 2. When you take this up, the exponent becomes a negative. This is already in a format that you can differentiate, because being able to differentiate, it has to be in this format for you to use the power rule, so that you can say this times the front and then minus 1 from the exponent, you see, because remember, that's what differentiation basically is. So here we've simplified. Now we can differentiate, and because now you can differentiate, it just means you can write f prime over here. You see, f prime is going to be equal to like negative 8x. Remove 1 from the exponent, that's like negative 3. and then plus 15 with the 4 here. Nice, very nice, right? Let us just move on. For 3 marks here, what did they want you to do? Hey, me, I want to change another color. These colors, I'm tired. Me, same colors. Let's see. Before you can definitely differentiate this, you have to simplify. So it looks like you're gonna have to like cross multiply first. So 1 times y here is a y. This times that there is like x minus 3. 1 plus x. Simplifying some more. You're not differentiating yet. You see, you're just simplifying. So x times 1 is like x. X times x there is like x squared. Negative 3 there. Negative 3x. And then you have x squared. Negative 3x plus 1. So it's like negative 2x. And then here, minus 3. You have not differentiated. You see, you have just simplified. Which is what most people fail to do when they differentiate. They fail to simplify first. You know, so as long as you can always simplify first, you're always going to be in a good spot. Excuse me, that was weird. Anyways, what you got here? Now you can differentiate, meaning you can put the d over dx here. So this is going to be 2x minus 2. Moving on. Functions, more functions. So I'm pretty sure you get the idea now. Functions and calculus. Yeah. How? When's in Johnny now? When's in Johnny? Anyways, let's see, what is this? The graph of g. This is a cubic function. You see, clearly a plane cubic function. It has the sketch, and then it says the graph of g intersects the x-axis at -2 and a 3, and then it touches the x-axis at I did that already. I said that already. K is the turning point of G. Okay, and then the graph of G cuts the y-axis at 9 coordinates 0. So automatically we know that D is a 9 because D is the y-intercept. And then it says here, for 4 marks, show that A, B, C, and D are equal to those numbers. Well, I mean, like, this one is pretty straightforward, because the idea is anytime you see that your x intercept is also a turning point, it just means that when you factorize this expression, right, you're going to have 2 brackets that look identical like this. You see, you're going to have 2 brackets that look like this. And then for this part here, you're going to have 1 bracket that looks like this. You see. Now, this factorized, you have to be careful. It is always going to be, let's see here, g of x here, it is always going to be, g of x is always going to be a up here with the first bracket and then those 2. Always, you see. So here you're going to multiply it out. You're going to multiply out everything and then work out a value for a. Now, to do that, it is quite simple. You're going to do the following. You're going to need to do the following. Let's just multiply out everything. So a is outside name. Let's multiply out which ones do you want to start with now? Let's just leave x plus 2 here. And then let's just multiply this. X times x is x squared. X times that, and then when you do it again, you're going to end up with like a -6. -3 times -3, that's a 9. And then a here, x plus 2. No, I have to multiply now. So x squared times x here is going to be x cubed. X times that is going to be -6x squared. And then positive 9x. This times that, positive 2x. 2 times the -6 is going to be like -12x, and then 2 times that is going to be like positive 18. Whew. Let's simplify what's inside here before we multiply the a. It's like x cubed. This does not have a like term, so you're just going to leave it the way it is. This has I feel like I made a mistake. Let me just slow down so fast. I know I made a mistake for sure. This times this is that, this times this is that, this times this is that, and then This times this, you see, I forgot the squared here. Yeah, so these are like terms. So it's like -6, right? -4, I mean -4 squared. These are like terms as well. Is that like -3? -3x and then plus 18. Oh, what is this thing doing? How did I get there now? Ish. Wait, so it just means a is gonna be a half, because if this is 18, then that's fine. Because when you multiply a inside, you're gonna have ax cubed minus 4ax squared minus 3ax, and then plus 18a, and then this is g of x, you see. And then remember, from background knowledge, we already know that you can just throw in a coordinate that the graph passes through. This is 0, coordinate 9, meaning you're gonna throw x as 0 there, x as 0 there, x as 0 there. So here, if you throw x as 0, you're gonna get 18a, of which x as 0 is just 9, and then here you have a is equal to a half. Just wait. I like it. Let me just write it like this so that people know what has happened. We have thrown in x as 0, it's just a 9 that comes out, because when you throw in x as 0, it's a 9 that comes out. Whew! So if a is a half, it just means that if you throw a half there, 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 you end up with these values over here. So let's just shrink this thing so that it's like smallish, you know. Yeah, it was much better. So all we have to do now is to go back here. A is already a half. Here you're gonna get b, right? So here it's like -4a is equal to b. So here it's gonna be b is gonna be equal to -2. For the other one, you know that -3a is your c value. A is a half, so this is just like -3/2 is c. And then for 18, you know that 18, we worked it out already, but we can always just do it again, I guess. 18a is a d, so here d is equal to 9. You've got your answers here. You've got your 1, 2, 3, and 4. Whew, lovely. Determine the x coordinate of the turning point K for 4 marks. You want the x coordinate of the turning point K. Very easy stuff, because now you have the full equation, you see. With the full equation of G, you're going to differentiate it, equate it to 0, get the x value of that turning point. So let us see. What you got? Come on, bro. What you got? Where's the equation? Hey, it's here. It's like a half x cubed. B was what? B was a -2, so it's like ish. Wait, was B a -2 or +2? Oh, yeah, it was -2 there. So it's like -2x squared. C was -3/2. Okay. -3/2 x, and then d was 9, +9. So coordinate of a turning point, it's not so bad. You just have to differentiate and equate to 0. So here let's just differentiate. 3/2x squared minus 4x minus 3/2, equating this to 0. 3/2x squared minus 4x minus 3/2. Yeah, definitely the quadratic formula, because I'm like, what you gonna do here, huh? What kind of superwoman do you think you are? Does that even make sense? What kind of superwoman do you think you are? Yeah, nah. What kind of superhuman do you think you are? Hi, Minangas. Let's just put this in the calculator after this. Minus b plus the minus b squared minus 4. What is a? A is like 3/2, and then like -3/2. Whoa, really? Oh wow, that's quite interesting. I guess it's just a coincidence, you know. So the whole thing over 2a, so it's like 2 times a. What is a? A was like 3 over 2, right? What a wow, man. What a wow. We have to get 2 answers. We have to get the one that has a smaller x value, because that's the one for k. Yo, anti-calculator, please help us, please. We are in a position where we cannot carry on without you, so please give us the answer. You know, please give us the answer. So here we're gonna get there. What you're gonna get here? We're gonna get x is a -3. No, negative a third. The other one is 3. So x is negative a third, or x is equal to 3. The 3 we obviously have to cancel it out because that's the one on the right hand side. So here, therefore, okay, you have -3 over there. We don't know what the y value is. The x value is this. Whew, moving on. For which values of x is it concaved up? So the graph is concaved up where the second derivative is bigger than 0, you see. So you working out where the graph is concaved up, it is quite simple. All you have to do is to work out where the second derivative is bigger than a 0. So let us get the second derivative. We have the first derivative of it already, so it's just going to be like 3 over 2x squared minus 4x minus 3 over 2. This is the first derivative. Yo, I put f instead of g. Oopsie. So this is already the first derivative. Let me just make sure I label it as the first derivative so that it is known by all parties that we have differentiated once. So here we're going to differentiate again. It's going to be like 3x minus 4. Wow. And then you're going to work out where this is above 0. You see, so you have to work out where the equation is above 0. So you're going to work out 0. Where is this equation above 0? The 4 goes over to that side. Divide by 3 on both sides. You're going to have x is equal to 4. X is bigger than 3. I mean, x is bigger than 4 over 3 is your final answer, you see. So that is that. You can just move on. You see, if you want to write it with x first, then be my guest, you know. For some people that are sensitive. Ha 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 ha. Moving on. 8.4. Determine the coordinate of P if the gradient of the tangent to the graph at P is equal to this. P touches G where G is concave up. Okay, so whatever the graph of G is, we can clearly see it's concaved up on the right side here. On the right side of P, because this is the part where it's concaved up. They said we need to get the coordinate of P if the gradient of the tangent to the curve at P is this. Okay, so whatever we're going to be doing, we need the gradient equation of G first, you see, because I mean, like, we're talking about gradient here. Before we can even fully understand the question, what we need to understand is we need the gradient formula, because I mean, like, we're talking about gradient and stuff like that, you know. So let's get it. Here it's like -3 over 2. So firstly, they said P is a point where the gradient is equal to this much. So to get the x value of P, we need the gradient. We need the x value where the gradient is -7 over 2. So gradient is -7 over 2. Let's get the x value where that is happening. So here, oh, quadratic equation again. You're nah. Hey. Even me, sometimes I get tired of the quadratic equation, because I'm always like, guys, come on, man. Come on, man. Come on, like, ish. No, man, no. Anyways, plus 7 over 2 here. And then here you have x is equal to, I need to, what is this going to give us now? I think it's a 4, because these are already denominators the same. -3 plus 7 is going to give us a 4. A +4, my guy. Anyways, x is equal to minus b plus minus. You have to write the whole formula again the whole time. Yeah, it is what it is, man. It is what it is. X is equal to minus b plus minus. I just think it's good practice, to write the formula when you're about to use it. Over 2, and then a is like 4 over 2, is it not? 4 over 2, yes it is. It definitely is, my bro. What is the a value? The a value is like negative 3 over 2. Whew. What is the final answer? Oh, got to use the calculator. He's so ain't about to work that out. Well, I don't think anyone would work that out in their head, because I'm like, hey, come on now. Let's see. Hey, I'm busy looking at this and I'm like, how did I get a minus there? Yeah, I was about to mess up good, yo. Excuse me, this is supposed to be a plus, not a minus. Because the calculator was like, it was giving me these weird answers. So I was just like, but how? But why? Anyways, this is going to give us 2 or 2 over 3. So clearly this x value here, if you look at where p is, it has to be smaller than 3. You see, so it cannot, but it could be one of those. Oh, no. But then it's after the point of inflection, you see. So you have to judge nicely here, because the point of inflection is at like 4 over 3. That's like above 1. So this one is not applicable. You see, because the value of p is above 1, you see. So if your value of p is where x is a 2, I mean, like, to get the y value, you can just throw that into the original equation. So into the original equation, let us throw in our value of 2 and see what we get, So let's see here, g 2 half 2 cubed minus 2 3 over 2 2. You're not the way I'm rushing, because my voice is like almost going. Okay, no, it's not almost going. Like, my voice doesn't go that easily. This is like 8, that's a 4, minus 4, that's a 0, and then minus 3 plus 9. Oh, that's supposed to be square here. This is like 4 times 2, that's like 8. So it's like 4 minus 8, that's like negative 4. Negative 4 minus... Hey, bosso, what's going on here? Hey, what is going on, man? Come on, this is 8, ne? Times a half, that's 4. 4 minus 8, that's like 4? No, 4 minus 8 is like minus 4. And then minus 4 minus 3, that's minus 7. And then minus 7 plus 9, that's a 2. Whew. Therefore, p is 2 coordinate 2. Very, very nice, man. Let's move on. Let's see here. Question 9. Sam has 16 meters, a 16 meter steel cable. Okay. To wrap around a cylindrical tank to strengthen the tank, as shown in the shaded part of the sketch. So this person has a 16 meter steel cable. Oh, they're going to tie it around the thing. Okay. Fine. It's 16 meters long. Okay, that's fine, I guess. Then they said here, show that the height can be written as this. Well, that's always easy, marks, like hello. Well, we know that this is like 2r and this is h, so it's like 2 times h plus 2 times 2r, right? This is gonna give you the 16. So h on its own here, you're gonna have 2h plus 4r here is equal to 16. Everything, h stays on its own with the 2. This is like 16 minus 4r. Divide by 2 on both sides. This is like 8 minus 2r. For 3 marks here, write down the volume of the tank in terms of r. Well, volume of the tank is quite easy here, because if you're going to write it in terms of r, remember, this is the radius. You see, the radius is r, because I mean, like, if this is 2r, it means that half of this is r. So the volume, remember, the volume of a cylinder is just pi r squared times height. In our case, our r is r, but then our height is given by this. So now we have the volume in terms of r, you see, which is going to be 8 pi r squared minus 2 pi r cubed for 3 marks. Thank you very much. Nothing crazy, nothing major, very simple stuff this. Now for the easy part, the 5 marks. The reason why I'm saying this is the easy part as well is because even though it's 5 marks, we're just going to be using the previous questions. Like, they gave us everything we need. They said, what must the radius and the height of the tank be so that the volume is a maximum? So you want to work out where is the volume a maximum. Now, if you're going to work out where the volume is a maximum, remember, this is something that is stated so many times. I mean, wherever you may have seen tutorials from myself, you see. Anytime you need to work out the maximum or the minimum of an equation, always differentiate it and then make it equal to 0, because it has the same effect as like working out a turning point or something like that. You see, you just differentiate and you equate to 0, because remember, a turning point is a maximum value or a minimum value. So here you're going to differentiate this, right? This is going to give you 16 pi r, because you're differentiating in terms of r. So here 2 times 2 pi is like 16r. I mean, 2 times 8 pi is 16 pi. And then here 3 times negative 2 pi is like negative 6 pi r squared. And then you have to make this equal to 0. You're going to work out a value of r that causes the volume to be a maximum. So the value of r here, let's see what you're going to get. 16 pi r minus 6 pi r squared. So obviously, if you put it in standard form, you can see nicely what needs to be done, in the sense that here you can just use the quadratic formula. Oh no, you don't. You can just take out a common factor. So it's like, I think 2 pi r is the common factor here. So let's see, 2 pi r, right? Here you're going to be left with like negative 3 r, and then here you're going to be left with like 8 only. Whew, what a wow, man. So obviously the one that's going to give you a 0 would be the one that would result in a minimum, you see, because this is going to be r is equal to 0. R being a 0 is obviously going to give you the minimum radius, so r is 0 is not applicable. The other option here is this is equal to 0. So here 3r is equal to 8, and then r is equal to 8 over 3. So this is the value of r that causes the maximum of volume. So if that's the value of r that causes you to get the maximum volume, it means that after getting this value of r, you just need to get the corresponding value of h that is also going to cause the maximum volume. So for h, we have this equation here, you see. So meaning in this equation of h, we can just throw our value of r and then get a final answer. So this is like h is equal to 8 minus 2, 8 over 3 is like 16 divided by 3. So 16 divided by 3, if you remove that from 8, let's just see what our calculator is going to give us. Oh, this is quite funny. Haha, it's also 8 over 3. Okay, it's not like haha funny, it's just like, it is what it is, man. It is what it is. 8 over 3 as well. So our value of r is 8 over 3. Our value of h is also 8 over 3. It's just a coincidence that they are both equal to each other. Moving on. Question number 10. Oh, please tell me this is the last one. Yo, we have 11. Oh, it's fine. Yo, my boys, I can feel my throat fighting. Wow, we're talking about Tom and Jerry now. Yeah, it is. Oh no, that's like such an overused statement. And I'm part of the guilty there. 2 marks. It says Tom and Jerry enter the Ironman competition. The probabilities that they will complete the race have been determined to be 0.85 and 0.67 respectively. So this is for Tom, this for Jerry. Then he says the probability that Tom and Jerry will complete the competition is independent to each other, meaning the probability of Tom completing times the probability of Jerry completing is equal to the probability of Tom and Jerry completing. You see, if you multiply these, it's going to be equal to the probability of Tom and Jerry completing because they're independent to each other. They said determine the probability, correct 2 decimal places, that both will complete the Ironman competition. Well, I mean, like, both is T times J. That's why these are easy 2 marks, because the probability of Tom completing is 0.85. The probability of Jerry completing is 0.67. So this is going to be equal to the probability of both of them completing, you see? T and J. Pink and the blue. Pink and the blue. So the probability of Tom and Jerry finishing. Yeah, see, man. Just write the J like that. You from in your anti-calculator. Let us see what you got. 0.57 if you round off to 2 decimal places, as they said. This says here, we need to work out the probability that only Tom will complete the competition. Wow. Ish. If they're independent events, then wait, let's see. What is this? Oh wait, no, this is not going to be too bad. Let's try and use the probability formula. The probability of Tom completing or the probability of Jerry completing is going to be equal to the probability of Tom completing plus the probability of Jerry completing minus the probability of Tom and Jerry completing. This is a formula that's on your formula sheet, you see. It's the addition rule of probability. So the thing is, we have this value, we have this value, and we have this value. They said the probability that Tom will complete the competition. Only Tom. That's quite interesting. This is at least one of them completing. At least one. Because it's Tom or Jerry completing it, you see. This is both of them completing it. Well, okay, so if this is the probability that they both completed, and this is the probability that they individually complete it, then the probability that only Tom completes it, then here we are. Here we kind of need to think outside the box. But it's a 2-mark question, so we don't have to overthink it. We actually just have to think light. Because let's see, the probability that only Tom will complete the competition. Only Tom. Okay, goodness. Okay, wait, what am I saying? The Tom completing is this much, Jerry is this much. The thing is, they're independent events, you see, so that's the crazy thing, you know. Yeah. Oh, wait, we have to work out the probability of Tom completing it and Jerry not completing it. We have to work out this probability. You see, the probability that Tom completes and Jerry does not, you see. So here we have to just think of the probability addition rule in this way, where this value is this one here. You see, this here is what's there. So here this has to be the probability that Jerry does not complete, and then this is the probability that Tom completes, and then this is equal to the probability that Tom completes or Jerry does not complete. Yes, like it's making things even worse, eh? And then I keep thinking of like a Venn diagram, but then a Venn diagram though, but they're independent events. But then yeah, it's fine. Is it fine? Yeah, I mean, I want to draw a Venn diagram. Let's see what happens if I draw a Venn diagram for this kind of a sketch. if I draw a Venn diagram, it's gonna be quite weird because it's just two events and they do have an intersection. So it's gonna look like this and it's gonna look like that. I'll just use two different colors, so that I can distinguish between the two. So with Jerry and with Tom, so this is what we know, right, about Tom and Jerry. We know that the circles represent the probabilities of, of them completing the thing. So what we know is with Tom, right, the probability that Tom completes the race or the competition is 0.85. What that means is this whole circle, the numbers in here have to add up to 0.85. So what we know is the probability that Tom and Jerry make it is 0.57. So in the middle here, you have to put 0.57. You see, like this, 0.57. Now 0.57 plus whatever this number is, it should give you 0.85. you see. So let us go and work that out quickly in the calculator. 0.85 minus the 0.87, let's see what that gives us. 0.85 minus 0.57, that's like 0.28. So the probability that only Tom wins is just 0.28, you see, because this is the probability that they both, no, the probability that Tom completes is this much. This is the probability that they both complete, you see. So remember, these two together have to add up to 0.85. So here our answer here has to be 0.28. That's going to be the final answer to say that's the probability that Tom wins alone, you see. So anyways, moving on, the next one says the probability that at least one of the two will complete the competition. Oh, I already spoke about this one. At least one completing is this probability here, this one. So let me just grab this and move it to the thing, because at least one means either one of them completes or both of them, you see, because at least one means both of them completing is also included. So let's see here. This is just going to be probability of Tom is like 0.85. Probability of Jerry is like 0.67, right? And then the probability of both of them is like 0.57. So this is like what? The probability of Tom or Jerry completing. That's at least one of them. So here, this is what is this going to be now. Let's check the calculator. Yep, 0.95. Very, very nice. Very, very nice and easy. We love to see it. We love to get marks. So we have to do what we gotta do to get the marks, you know what I'm saying? Let us move on. Let us move on with the life and times of us truly. So the last question. Oh, this feels so good. Ooh, this feels so good. Ooh. It says the digits 0 to 9. The digits 0 to 9. So we have 10 options here. Are used to create a 5-digit number for a lucky draw for the Great of fundraising. The digits may repeat. Okay, the numbers lie between 10,000 and 20,000. Okay, then it says these numbers are written in pieces. These numbers are written on pieces of paper and thrown into a bottle. Oh, excuse me. And then they say, yeah, to win a prize, you have to draw a 5-digit number that has at least 1 6 and the digits may not repeat. Determine the number of papers in the bottle. Okay, that's the first question. The number of papers in the bottle, I mean, like, you have to think of it, right? It's a 5-digit code, so it's like 1 2 3 4 5. The 5-digit code, remember they said numbers may repeat, but it has to be between 10,000 and 20,000. So the number that can be here can only be, you only have 9 options here, because remember the number here cannot be a 0. You see, so you have 9 options over here. The moment you put one number here, you still have 10 options here, because remember numbers can be repeated. You still have 10 options here, you still have 10 options here. But then, oh no, we have to start again. Your number has to be between 10,000 and 20,000. So meaning the number here can only be a 1 or a 2. You see, so you only have 2 options here. The moment you put one number here, you still have 10 options, you still have 10 options, you still have 10 options. Oh no, oh shucks. Yeah, I actually have to do this a different way. So we're going to use this to represent numbers that start with a 1, you see. So numbers that start with a 1, it means that you have like one option here, you see, which is a 1. The moment you put a 1 here, you have 10 options, here you have 10 options, here you have 10 options, here you have 10 options, you see. These are numbers that start with a 1. You have a 1 over there. And then you also have numbers that start with a 2, you see. The numbers that start with a 2, you only have one option, which is 20,000, you see. So you're going to have a 2 here. So you have one option for this front here. And then you have technically one option here, one option there, one option there, one option there, you see. So ones that start with a 2, it's just one option. Ones that start with a 1, you have plenty options, you see. 10 times 10 is 100, times 10 is 1,000, times 10 is what? I don't know how many zeros. It's like 1, 2, 3, 4 zeros. 10,000. Bro, you couldn't say 10,000. Magangi. That's embarrassing, eh? 10,000. So you have 10,000 options plus 1. So it's like 10,001 options. Interesting, right? Or is it? Well, it is what it is, man. Hey, yeah, that phrase, it is what it is. Yeah, it ruined our lives, yo. But then at the same time, I'm like, how is it 10,000? Shouldn't I be like subtracting 1 actually? Because they say here, determine the number of papers in the bottle. Digits made 5-digit number. Oh shucks, the number. Okay, no, the number. The number has at least 1 6, and the digits may not repeat. Oh no, that's to win. They say that the numbers lie between 10,000 and 20,000. Oh, shucksify, bro, shucksify. Okay, so if it's between 10,000 and 20,000, then it means 20,000 is like not included. Okay, so that leaves us with like 10,000 options. But then if it's between 10,000 and 20,000, it means 10,000 itself is not included. Okay. So what it means is we have to say they have 10,000 options. 10,000 options minus 1. The one that we're subtracting is the option that has 10,000. You see, because the option where you have 1 0 0 0 0, that one you cannot take it, because the numbers have to be between this and that, you see. So you have to take a number that is like 10,001 going on and on and on and on until like 19,999. Yeah, so this one was quite tricky. Like, yo, ooh, hey. Yeah, but you're seeing it, eh? You're seeing. I think this is the one paper where towards the end, yeah, it's just flopping, but not really. It says here, what is the probability that a person who selects a paper randomly from the bottle will win a prize? Show your calculations. Ooh, yeah, this one seems like it's gonna be crazy, eh? So it says here, to win a prize, you have to draw a 5-digit number that has at least 1 6. Okay, and the digits may not repeat. Okay, so when they ask you to calculate a probability where at least one thing happens, what you need to do is you need to work out the probability of that thing not happening at all, and then you subtract it from all the outcomes possible. So what I mean is, you have to work out the probability that you have no 6's at all, and then subtract that from this. What you have left is the options that have at least 1 6. So what I mean is, in a 6-digit number, right? I mean, in a 5-digit number. In a 5-digit number, we know that options that start with 1, I mean, our numbers can only start with a 1. That we have already identified. And then we have also identified that in total we have like 9,999 options, because we have to remove the option of 10,000 specifically. So technically, anyways, let's just carry on. So that being said, let me put here options. 999 options. So that being said, we need to work out how many numbers will not have 6 at all. You see, so here, if a number is not going to have 6 at all, firstly we said all these numbers have to start with a 1, so there's only one option that goes here. The moment you put one number here, what you have to remember is, that we have to work out how many options do not have a 6 at all, you see. But then the other strange thing is, they say here digits may not repeat. Digits may not repeat. Okay, well, it's fine. If there's a 1 here, then it means that you have already used one number. Here you only have 8 options only, because remember we said we're working out the options where you have no 6's at all. So if you have no 6's at all, then you have 9 options total. You see, let's say here 9 options total in terms of numbers to choose from. So you have used one already. So here you only have 8 options. The moment you use one number here, you only have 7 options. The moment you use one number here, you only have 6 options for this one. The moment you use one number here, you only have 5 options for this one. So the number of numbers that don't have a 6 is these ones here. 8 times 7 times 6 times 5. So let's see what that gives us in the calculator. In the calculator, let's see here. This is giving us 1,680. Okay, so this is the ones that have no 6's. No 6 is okay. So this, we have to remove it from all the possible numbers that can be generated according to this criteria, because this criteria says digits may not be repeated. So if digits may not be repeated, it means that for the 5 slots here, we know that firstly, I mean, a number has to start with 1. That we have already said. The moment you put 1 in here, you have 9 options here, because remember we're trying to work out all the possible options. Here you have 9 options. The moment you put 1 there, here you have 8, and then 7, and then 6 at the end. So all the total possible outcomes, where we only consider the restrictions that they told us, we are going to get the 3024. So this 3024, right, this is to say that amongst the numbers that have digits that don't repeat, you have a total of 3024. Now, amongst those numbers that have digits that don't repeat, you only have 1,680 that have no 6's at all. You see, let me repeat. When you think of codes, or when you think of numbers that have digits that don't repeat, you have a total of 3024 numbers. Now, amongst those numbers that have digits that don't repeat, 1,680 of them have no 6's at all. So what that means is, from this 3024, if you subtract all the ones that don't have 6's at all, you end up with ones that have at least 1 6 in them, you see, because this is all the numbers that have digits that don't repeat. This is all of them, you see. And then this is the ones that have numbers that don't repeat but then have no 6s at all. So if you say everything minus the ones that don't have any 6s, you're going to be left with the ones that have at least 1 6, you see. So the numbers that have at least 1 6, the probability of you getting those is just 1344 out of the total outcomes without any of the restrictions that they mentioned, because that's how you're going to work out the probability of someone winning. Because the probability of someone winning, you have to include everyone that even would not fall into this category of digits not repeating. So this probability in your calculator is just 0.13. This I can safely say was a level 5-6 question, like no cap, level 6/7. Maybe even put 7 there. Why put 6 and 4 5? Oh, and it's the last question. Oh, nice. Oh, I didn't notice. Oh, yeah. Towards the end, this paper was showing some heat, but hey, we conquered him. We tried. Sham. We tried. So that is that. And obviously, as I mentioned already, if you see that you still need help, like to understand and all that, then you really do need to take advantage of this 50% off coupon. Let me just try and go back to it so that you can see the details of it and stuff like that. You see, it's quite important that you take this opportunity. See, it's just a 50% off everything on the course platform. Just BYB50 at the checkout. This is something that you can do to help yourself. And let me actually paste it right at the bottom there. Why don't it? Well, just like stalling and stuff like that. So if this video was helpful, then I mean, you know what to do. Or if you don't, then you can give it a thumbs up. You can let your people know that such videos like this exist, where you can go through an entire paper from start to finish without like leaving any question out, you know, because that is how we are do what we are doing. So and you can hear my stomach. Okay? Now I'm hungry. I'm so hungry right now. I'm like so hungry. It's not even funny. But 50% off at this website. And this is the coupon code. If you need to like find out more information and all that shandies, don't worry about it. Just hit me up on IG, or you can send me an email at this email address up here. And then obviously on IG, if you need to talk on WhatsApp, I'll just give you the WhatsApp number, and then we can communicate over there, you know. Anyways, I am basically just done now. Like, I guess I'll catch you in the next video.